Otherwise, okay. So last week, if you recall, we already have completed our discussion on chi-square. Right? We have already completed our discussion on chi-square on Sunday, and earlier on the normal class time, we have our topic on ANOVA. So that means for our final exam, we have only 5 topics to be included. Only 5. Right? So that means it will be much more manageable for you to prepare and get prepared for the final exam. And the 5 topics include 1, ANOVA, 2, chi-square, 3 will be our topic today, which should be on Spearman Rho correlation. And then 4, our topic next week will be on Pearson product moment correlation. And finally, our last topic to be included in the final exam will be simple linear regression. So the last topic is simple linear regression. So that will be the topic to be covered in our final exam. And for chi-square, I have received one assignment. Is it one assignment or none? Or is it just assignment 5 from one of our friends? So I mean, many of you still owe me your assignment 5 and assignment 6. Is that right? 5 and 6, and the deadline, the due date will be this Saturday. And today is Thursday. That means you still have ample time to work on your assignment. As usual, earlier, based on my observation, students are excited to submit the assignment. But to me, don't have to be too excited to submit your assignment, because we want to make sure that before you work on your assignment, you really have understood and have full knowledge on the topic. And as I did suggested last after the ANOVA class, how we can strategize to make sure that we learn all the topic fully by before we actually work on the assignment. So I would expect that now you come down and you really follow the step, and you start to work on your assignment once you really understood the topic. And when you work on your assignment, you just rely on the formula sheet, not to rely on the notes. If you rely on your notes for your assignment, then you will be caught in your final exam, Because why? When come for the exam, you are not supposed to bring your notes. You cannot open your notes. But if you acquaint yourself with your formula sheet, then formula sheet will be with you during the final exam. So that means you will be more prepared. And
Doctor,
yeah.
Bruce,
Yeah.
There's someone still in the waiting room.
Oh, few students waiting in the waiting room. Okay.
Yeah.
All right. Okay. Now I have already admitted how many of them? 2, 4, 6, or 9 of them. Okay. All right. So now, so make sure tune your study, tune your strategy for your preparation for your final exam, so that we are more prepared for our final exam. When we are more prepared for the final exam, naturally you should be able to perform better. And I have already posted in our WhatsApp the simulation, how to strategize, how can you plan for whatever grade that you plan for this subject. So you can use that simulator to play around, and then make sure starting from assignment 5, 6, 7 until 9, never get less than 10, or actually never get less than 9. Maybe 10 maybe too much, but actually everyone should be able to get 10, because after all, this assignment is open book, and you can check your answer with SLT as well as SPSS. Therefore, the expectation is it is viable for you to get 10. And we have quite a number of students from assignment 1 until assignment 4 and 5 for the for section 3. They get 10, 10, 10, 10, 10, 10. So that means it's not impossible to get 10 for all your assignment. Right? So whatever that you get for the early assignment, let it be. But now we can strategize to make sure that from this coming assignment that you are going to submit to me, 5, 6, 7, 8, 9, and 10, and 9 up to 9, make sure don't get less than 10, or the least will be not less than 9, so that you can make sure that your overall grade for this subject will be much higher than whatever that you get in your midterm exam, especially if you are not doing that well in the midterm exam. So this is the platform that we can do in order to improve our performance. And I'm sure that everyone should be able to unleash your potential to improve your overall grade for ERS 5950. Okay, so for chi-square, we have discussed two different types of chi-square for goodness of fit and chi-square for test of independence. Is that right? Is it right? Okay, so that means starting from chi-square until simple linear regression, our focus will be on relationship or association between variable. No more comparison between group. I mean, our focus of all these 4 statistics will be on relationship, but not for comparison between group. So make sure we know when to apply for chi-square for goodness of fit, and we know when to apply for chi-square for test of independence. Okay, so any question if you have regarding our last topic on chi-square? Sariza nampak complete dengan Sariza, dengan dia punya headphone kan. Itu dah memang kira kalau pergi TV1 tu memang dia terima terus lah. InsyaAllah. Erda pun boleh tanya lagi, tapi tak boleh lawan dengan Sariza sebab dia punya nampak lebih besar lagi kan. So insyaAllah. Okay, so any question on chi-square, if there's any? Are you happy so far towards your preparation for the final exam? Helwa, on behalf of our friends, any question? Helwa?
I'll try my best.
Inshallah. So inshallah, everyone will also be trying their own best for this final exam, and inshallah, I will give a full support. But you have also to be active. I mean, if you don't not to be proactive, then not much that I can contribute towards your coming performance. But if you are proactive, I mean, you ask question during class in a session, or you ask or post a question in our WhatsApp, then inshallah I will try to respond, and I will try to do my best, my very best, to help each and every one of you to perform. Eswaran, we want to help everyone. You are now in your home, at home?
Yes, bro.
Okay, now no more in your car. Okay, good. You are more, will be more comfortable at home rather than in your car for the class, inshallah. Okay, so since it seems that means no question from our friends, so my expectation is for chi-square, each and every one of you really have understood the chi-square for goodness of fit, as well as chi-square for test of independence. And for that, you are ready to work on your assignment 6, and you are ready to submit your assignment 6, inshallah. Okay, so now let's go for our topic today, which will be on Spearman Rho correlation. Spearman Rho correlation. Okay, so when we talk about correlation, in most studies done by either by masters, PhD student, or even by lecturers or by researchers, one of the elements that we include in our study is we want to determine relationship between variable. I mean, earlier when we discussed on chi-square for test of independence, we have already discussed 3 types of coefficient, some sort of correlation coefficient, which we call them as symmetric measures. Remember, we have 3 symmetric measures when we discuss about chi-square for test of independence. Li Zufeng, could you recall the 3 symmetric measures that we discussed in chi-square for test of independence? Just to make sure that okay, what are they? One will be
the first one is a phi coefficient.
That one, oh, mashallah, good. Good sound. Phi coefficient. Second,
Second is a contingency coefficient.
Contingency coefficient, C. Okay. The third,
Third is a Kramer V coefficient.
Kramer's V coefficient. I mean, these three symmetric measures are actually a form of your correlation coefficient. But this correlation coefficient will be applied if you are, if you both your variable are categorical. I mean, if your IV and DV are categorical, or maybe your IV or DV are interval or ratio, but one of the variable, the dispersion is not normal. Then no, for chi-square, of course, will be categorical. I'm confused with the opinion with the Spearman Rho. I mean, if both your variable are categorical, either nominal or ordinal, then we have to apply for chi-square. Is that right? In order for you to apply for the chi-square, I mean, when you apply for chi-square, if you want to explain the nature of relationship, the strength of relationship between the two variable, then we can use these three coefficients, which are phi, contingency, and Kramer's V. Okay, Lim Kuan Li. When to apply for phi, Lim? When to apply for phi? What is the size of your contingency table for you to apply for phi coefficient?
2 times 2.
Okay, when you have 2 by 2, what do you mean by 2 by 2? 2 row and 2 column. That means the size of your contingency table is 2 by 2. Then we apply phi coefficient in order to explain the strength of relationship between the two variables, right? Okay, when is the case that we need to apply for contingency and Kramer's V? Zhu Aifang, you have already opened your notes, Zhu Aifang. When to apply
Yes.
for,
It is more than 2 by 3.
that means not more than 2 by 3, but more than 2 by 2. That means it can be 2 by 3.
No, more than 2 by 2. Yeah.
Yeah, 2 by 2. That include 2 by 3, 3 by 2, 3 by 4, or whatever. I mean, if it is not 2 by 2, if it is more than 2 by 2, then we apply either contingency, the C, or we can also apply for Kramer's V, the V. That means we need to select the right coefficient to explain relationship, the strength of relationship between two variables. So that means if that means this will be one form of correlation method, correlation coefficient that we can use in order to explain the strength of relationship between variables. But in this case, we just need to explain the strength, but not the direction. We don't have to explain the direction because direction is not relevant because our data is categorical. So we just explain based on the three coefficient, the strength of relationship between variable. But starting from Spearman Rho, in relation to the coefficient that we're going to propose, the correlation coefficient that we will derive from the analysis, we should be able to explain the strength. At the same time, also we can explain the direction of relationship between variable. I mean, it can go beyond what chi-square have to offer. I mean, chi-square, when we explain the three coefficient, the phi, contingency, and Kramer's V, we can only explain the strength of relationship between the two variables. But starting from Spearman Rho, followed by Pearson correlation, and finally simple linear regression, we can explain the strength. In addition, we can also explain the direction, whether the relationship is positive or negative. That is something that we can add on when we explain the nature of relationship between variable, when we go for Spearman Rho, Pearson correlation, and simple linear regression. Okay, now that is basically the start of our discussion on relationship, starting from the chi-square for test of independence, and then we proceed with this topic here, Spearman Rho, and then next week will be on Pearson, and finally simple linear regression. Okay, we start with Spearman Rho. Okay, this Spearman Rho, as what we discussed for chi-square, fall under non-parametric statistic. Eswaran, nampak serius itu, Eswaran. When we say non-parametric statistic, what does it mean? What do you understand about when we say statistic fall under non-parametric statistic? What does it mean?
Maybe normal normal distribution.
Okay, that means it doesn't require for the data to be normally distributed. All right, I mean it doesn't require. But if you were to apply parametric statistic, we need to confirm. We need to make sure that our data, the distribution, are normally distributed. That will be the difference between parametric and non-parametric. Parametric require that your data must be normally distributed, while for the non-parametric statistic, it doesn't require. It doesn't require. I mean, if it is normal, also you can apply. If it is not normal, also you can apply. That's what we have discussed earlier when we discussed about the different type, the three different type of statistic, descriptive and inferential, parametric, non-parametric, univariate, bivariate, and multivariate statistic earlier. Okay, so this Spearman Rho correlation fall under non-parametric statistic. I mean, it doesn't require that your data to be normally distributed. Okay, another name for this Spearman Rho correlation is rank ordered correlation. Rank ordered correlation. That is another name for your Spearman Rho correlation. Why they call that as a rank ordered correlation? Because after this, when we go for our calculation, for the RS, the calculation is not based on the actual score. The calculation is not based on the actual score, but our calculation will be based on ranking of your score. Ranking of your score. I mean, we need to rank X, we need also to rank Y. I mean, we rank X, we assign as RX. RX here refer to rank for X. RY, rank for Y. I mean, we need to rank X, we need to rank Y, and then our calculation will be based on ranking of your score for X as well as scores for Y. That's why they call this Spearman Rho correlation as rank ordered correlation. That is just another name for Spearman Rho correlation. Okay, purpose. What is the purpose of using this Spearman Rho correlation? Okay, the purpose here is we want to determine relationship between two rank ordered variable. We want to determine relationship between two rank ordered variable. That means your X will be rank ordered, and then your Y will also be rank ordered. This will be the purpose why we need to run for Spearman Rho correlation. Determine relationship between two variables, and the two variables are rank ordered. Okay, next. Okay, in case if you have any question, feel free to stop me. I will be happy to stop and to explain further if I can. Otherwise, I will have to go for my additional review to answer your question if I can't answer it promptly. So I will try to. But of course, inshallah, as much as possible, I should be able to answer whatever question that you have pertaining to the topic that we discussed, inshallah, today. Okay, requirement. The second information that you need to acquire or you need to understand about this Spearman Rho is requirement. I mean, what should be the scale of measurement for your IV and your DV? Okay, the basic requirement here will be the scale of your measurement for your IV and DV must be ordinal and ordinal. Ordinal and ordinal. Remember when we discussed on chi-square for test of independence, we mentioned that the scale of measurement for your IV/DV must be nominal or ordinal, but at least one of the variable must be ordinal scale. That means ordinal nominal and nominal, nominal and ordinal, or ordinal and nominal. But if it is ordinal and ordinal, that means your IV is ordinal, your DV is also ordinal, then a better statistic will be this Spearman Rho correlation. Everyone get it? Can you see the link between chi-square and Spearman Rho? If your data are categorical, if it is nominal and nominal, of course we apply for chi-square. Nominal and ordinal, and also apply for chi-square. Ordinal and nominal, that is meant for chi-square. But if it is ordinal and ordinal, that means if your IV is ordinal, your DV is also ordinal. A better statistic will be Spearman Rho correlation. Right? Okay, that is the basic requirement. But in most cases, we apply for this Spearman Rho correlation, the case whereby both your DV and IV are interval or ratio scale. both your DV and IV are interval or ratio scale. But there is a but here. But at least one of the variable, the distribution is not normally distributed. Right? Both IV and DV, the basic requirement is ordinal and ordinal. But in reality, in most cases, we apply for Spearman Rho correlation when your IV and DV are interval or ratio, but one of the variable, the distribution is not normal. And then we apply for Spearman Rho correlation. But in case if it is interval ratio for both IV and DV, and both the variable are normally distributed, we don't apply for Spearman. If both the distribution for the two variables are normally distributed, we don't apply for Spearman Rho. But instead, which statistic to be applied? Any answer from our members here? If IV and DV are interval ratio,
Pearson.
yes, the right statistic will be Pearson product moment correlation. You see, you can see the link from chi-square and then to your Spearman Rho and to your Pearson product moment correlation, right? So make sure you get that basic concept of me right, so that you at least you can see the link in terms of the requirement to apply for your statistic. All right. So that means in this case, in reality, in most cases, we apply for Spearman Rho correlation when your IV and DV are either interval or ratio scale, but one of the variable, the distribution is not normal, or both the variable, the distribution are not normal. We apply for Spearman Rho correlation. Okay, Iswaran, you get it? You get that?
Yes,
okay, good. So make sure you get everyone, not just any specific individual, but everyone. I mean, when I share, when I deliver through this our session like this, we want to make sure that everyone get the concept right. Okay, so that will be the requirement to apply for Spearman Rho correlation. Okay, proceed further. Okay, just to give the overall picture of what you need to understand about Spearman Rho correlation. Okay, this is what you need to understand based on what is listed in this slide. If you get all this, that means you have the essential knowledge on Spearman Rho correlation that will help you to understand your Spearman Rho, and that also will help you to run your data analysis if you need to apply for Spearman Rho correlation. So what is it that we need to understand? Okay, when you go for Spearman Rho, it has two dimensions as compared to when we discuss on t-test, when we discuss on ANOVA, when we discuss on chi-square. These statistics are inferential statistic. T-test is an inferential statistic. ANOVA is an inferential statistic. And chi-square is also an inferential statistic. But when it comes to Spearman Rho, it has both descriptive as well as inferential dimension. I mean, it has two dimensions within that Spearman Rho, right? As compared to t-test, ANOVA, and chi-square. Okay, what does the descriptive component comprise? What are the element that include under descriptive element of your Spearman Rho? Okay, for descriptive element or component, the first thing that we need to do will be we need to calculate RS. If we were to do manual calculation, that means we need to calculate RS. If we were to run in SPSS, we need to derive RS from the SPSS output. That is the first thing that we need to do in the descriptive component or dimension. We need to calculate, or we need to derive the RS from SPSS output, or we need to calculate manually. Okay, once you have derived or calculated for the RS, the next thing under the descriptive will be, we want to describe. What is it that we need to describe? We need to describe two things. One will be the direction of the relationship based on the RS. And when we talk about the direction, I mean it can be positive, it can be also negative relationship. Second will be, we want to describe the strength of relationship between the two variables. When we talk about strength, we will also applying the Guilford rule of thumb in order to explain the strength of relationship between the two variables. I mean, that constitute your descriptive component for Spearman Rho correlation. We calculate if it is manual, or we derive the value for RS based on species output. And then from that value for your RS, then we need to describe what is it that we need to describe. We need to describe the direction, either it be positive or negative. And we also need to describe the strength of relationship with, between the two variables using Guilford rule of thumb, where if it is less than 0.2, negligible relationship, 0.2 to 0.4, low relationship, 0.4 to 0.7, moderate relationship, 0.7 to 0.9, high relationship, more than 0.9, very high relationship, based on Guilford rule of thumb. Okay, that complete our discussion on, not discussion, our exposure, basic exposure on what constitute the descriptive component for Spearman Rho correlation. Calculate or derive, and then explain. What is it that you need to explain? Direction and strength of relationship between the two variables. Okay, that take care for descriptive component or dimension. The second component or the second dimension for Spearman Rho correlation will be the inferential component. Inferential. I mean, when we talk about inferential, normally we relate to something, right? Okay, no Lisa. Okay, you have compared your template against my template, right? And then we can use, now you have the choice. Either you use your template or you can use my template to plan for what should be your grade for the final exam. Okay, my question is, when we talk about inferential, normally when you talk about inferential, it relates to something, right? What is that something that we relate to?
Test hypothesis.
Right. I mean, when we talk inferential statistic, we always relate it to testing for hypothesis or hypothesis testing. That will be what we need to do in the inferential component for Spearman Rho correlation. What type of hypothesis that we are testing? We are testing on the significance of the relationship. We want to know whether the relationship is significant or non-significant. Earlier, when we described about the strength of relationship and the direction, we cannot see whether the relationship is significant or non-significant. We can only describe the direction. We can also only describe the direction, the strength of relationship, full stop. But if you want to know whether the relationship is significant or non-significant, then we need to proceed to the second dimension of Spearman Rho, where we go for the inferential component, where we are testing for the hypothesis. Okay, when you talk about testing for hypothesis, generally we have 5 steps in testing for hypothesis that include, first of all, state your HOHA. Second step will be, if it is manual calculation, we calculate our test statistic. Step number 3, we determine our critical value. Step number 4 will be decision, and finally will be conclusion. That will be the 5 steps in testing for hypothesis if you are doing manual calculation. But now, if you were to observe on the screen, for your manual calculation, we have 2 different procedures. The first procedure on top, the second procedure at the bottom here. And then this procedure is based on your sample size. Okay, the procedure is differentiated by your sample size. If your sample size is less than 10, then we apply this 5 steps. If it is 10 or more, then we apply this 5-step procedure. Okay, let's look at the first procedure where if your M is less than 10, that means if it is 5, 6, 7, 8, and 9, then this will be the 5-step procedure that you need to follow in order to test for the hypothesis. What are the 5 steps? Step number 1, state HOHA. Step number 1. Step number 2, luckily in step number 2, if it is less than 10, then we don't have to calculate additional statistic. Whatever RS that we have calculated earlier, we just need to report that value here in step number 2. Report your RS that you have calculated in the descriptive dimension or component. Just report. No need to calculate another statistic. We just report the RS. Step number 3, we need to determine critical value. Okay, now, in order to determine the critical value, then if you were to open your booklet, the table is on page 14. Open your booklet on page 14. You are given the Spearman Rho table. Spearman Rho table, where you are given two table on the left and table on the right. Table on the left if you are testing for two tail, table on the right if you are testing for one tail. Right? So, and then if you want to determine your critical value, it is not based, I mean, here we don't have to worry about degree of freedom. I mean, in order to determine your critical value, you just need to know what is your alpha and what is your n. I mean, it's not, we don't have to calculate degree of freedom in this case, just based on your n and alpha. And of course, either you are testing for two tail or one tail. That is, if your sample size is less than 10, then this will be the table for you to determine your critical value in step number 3. All right, step number 3. Step number 4, we want to make decision as usual. In order to make decision, we just compare RS, which is the calculated RS, against the RS critical from table page 14, right? From your Spearman Rho table, and you should be able to make your decision. What should be the decision criteria? Okay, what is our decision criteria, Erda? When to reject? If we were to compare RS against critical RS, when to reject?
RS is larger than critical. Calculated RS is larger than critical, then we reject the H note.
That's right. I mean, if
it is less, then fail to reject.
Okay. If your calculated RS bigger than or equal to, that means include equal to, if it is greater than or equal to your critical RS, reject HO. If it is less than critical RS, fail to reject HO. That means if you look at the pattern will be the same from our T, from our F, from our chi-square. The same pattern is applied in order to make your decision, right? If calculated statistic bigger than or equal to critical value, reject HO. If your calculated statistic less than critical value, fail to reject HO. I mean, the same pattern is applied here. And that will be in step number 4 for your decision. And finally, we should be able to proceed to the conclusion. That will be the 5-step for the testing for hypothesis. If your n is less than 10, I mean, if the maximum sample size is 9, then we apply this 5-step procedure. However, if your sample size is 10 or more, then we use the second 5-step procedure. What is the difference? Okay, step number 1 still maintained. That means step number 1 still retained, where we state HOHA. That means the same HOHA that we apply in the earlier procedure will also be applied here. That means we state the same HOHA. But in step number 2, we don't report the RS. We need to calculate another statistic, and that statistic will be, we need to calculate T value. But this T value is not the T value that we applied earlier for PET sample and independent sample t-test. But this T value is used to test on the significance of your RS. I mean, we are not going to use the same formula, but the formula that we're going to calculate for this RS will be T equal RS minus rho S divided by square root of 1 minus RS square divided by n minus 2. Where do you get that formula? Okay, please open your formula sheet. Please open your formula sheet on page. Okay, on page 6. Formula sheet on page 6. Is you have only one formula, right, for Spearman Rho to calculate for your RS, where RS equal 1 minus 6 summation D square divided by n square minus 1. Where is the formula to calculate T for your Spearman Rho? It's not there, is that right? Is there anything to worry? Is there anything for you to worry for exam? Because the formula for T, the formula to calculate T for Spearman Rho is pardon me?
Page number 7, Prof.
Okay, I mean, it is safe by page number 7. I mean, you can apply T for Pearson product moment correlation, where if you look at the formula, T equal R minus rho divided by square root of 1 minus R square divided by N minus 2. Because when you go for your Pearson, your correlation coefficient, the symbol is just R. For our Spearman Rho, the symbol is R and then S. S is this subscript, right? So that means you just add on to the formula RS minus rho S divided by square root of 1 minus RS square divided by N minus 2. Don't change the one on page 2, page 7. But you may want to write somewhere on page 6 the formula under Spearman Rho. Under Spearman Rho, you need to write T equal RS minus rho S divided by square root of 1 minus RS square divided by N minus 2. I mean, so that you will not be confused. Even though the formula is there on page 7, but page 7 is meant for Pearson correlation. But for Spearman Rho, we just include the subscript S, RS, rho S, and RS square. Right? So you have the formula. Don't worry, the formula is there. You can refer to that formula in order to calculate for the T. If you need to calculate T for your RS in order to test the hypothesis, if your sample size is 10 or more. I mean, in step number 2, we need to calculate another statistic, and that statistic will be T. And the formula is T equal RS minus rho S divided by square root of 1 minus RS square divided by N minus 2. Okay, so that will be step number 2. Step number 3, we determine critical value. But in this case, since we calculate T, we don't go to RS table, but we go to the normal T table on page 9. If you look at page 9, the normal T table that we refer to when we go for independent sample t-test as well as PET sample t-test. I mean, in order to determine your critical value, this will be the table, T table on page 9, in order to determine your critical value in step number 3. Okay, that will be step number 3. Step number 4, as usual, we make our decision by just comparing T calculated against T critical. And as we mentioned earlier, the pattern will be the same. If your T calculated is bigger than or equal to your T critical, reject HO. Otherwise, if your T calculated is less than T critical, fail to reject your null hypothesis. I mean, the decision criteria, the pattern will be still the same. And finally, the final step will be conclusion. And that will be what you need to understand about Spearman Rho correlation. These are the essential information or knowledge that you need to understand about Spearman Rho, which comprises 2 dimensions, descriptive, inferential. Okay? Any question about up to this point? Is it clear so far? Okay, good. Alhamdulillah. So make sure we don't want to have any unambiguity or anything that is confusing or something that maybe we don't really understood. So if there is any of such matters, then clarify during our class discussion, or otherwise we can clarify in our WhatsApp. But if it is here, I mean more lively, is it right? I mean, I can explain if my explanation is not good enough or not enough, then you can ask me further. But if it is in WhatsApp, maybe sometimes it's quite difficult, is it right? So it will be better if you have any question, then put your question to me. That's why, as I did suggested earlier, before coming to the class, you need to go through, I mean, as much as possible, at least to browse through the topic on, in this case, on Spearman Rho, so that when you browse through, when you read through, at least you know which part that you may that you understood and which part that you have problem to understand. Then this will be the opportunity for you to clarify. But if you don't read through before, then you are not sure which part that you understood and which part you don't. You have problem to understand. So that's why I would really suggest that before coming to the class, you need to at least browse through. Better still, if you were to go through in detail so that you test your understanding whether which part of the material that you understood and which part of the material that we share in the slide, which are not understandable, the way where you can get your clarification during our class discussion, inshallah. Okay, let's proceed further. If there's no question. Okay, what to expect? Okay, first of all, we calculate RS, as I did mention earlier. And then how to calculate RS? This is the formula. RS equal 1 minus, this is another element. I mean, one and the second element is two separate things. We don't combine them together because there are cases whereby students make mistake. They include 1 minus 6 summation d square, the whole thing divided by n square minus 1. That is wrong. 1 is by itself, 1, and then minus, and then the second element will be 6 summation d square divided by n square minus 1. That will be the formula to calculate for your RS. What is RS? RS here is Spearman Rho correlation coefficient. Spearman Rho correlation coefficient. That is RS, the symbol. Okay, that means in order to calculate for your RS, there are only two variables. And that means only two variables. What are the variables? First of all will be D, and in this case will be D squared. Second will be N. And I mean, if you know the D square, if you know the N, and you should be able to do calculation for your RS. You need to know what is D square, you need to know what is N, and then you can just apply that into this equation, and you should be able to solve for your RS. And these 1 and 6 are constant. Every time will be 1, and here will be every time will be 6. Don't change to other value, right? So 1 minus 6. If you change, then for sure your answer will be wrong. Okay, 1 and 6 will be constant. The variables are d squared and n. Okay. Once you calculate your RS, what should you do? You need to explain. You need to describe what is it that we need to describe, direction of the relationship as well as strength or magnitude of the relationship between the two variables. That will be what we need to do. We calculate or we derive from a species output, and then we describe what is it that we need to describe, direction of the relationship, whether positive or negative, and also the strength, whether it is negligible, low, moderate, high, or very high relationship between X and Y. In addition to that, then we may also want to test for the hypothesis. And the hypothesis that we are testing is, we are testing on the significance of the relationship, whether the relationship between the X and Y is significant or non-significant. So that are basically the elements, are the things that we need to discuss and we need to understand about Spearman Rho correlation. Okay, earlier we mentioned about the two dimensions, right? Dimension for descriptive, dimension for inferential. Okay, what constitute the descriptive component, as we have already discussed earlier? The first thing will be we calculate or we derive RS, and then we describe direction and strength. That will be the descriptive component for Spearman Rho correlation. The inferential component will be when we are testing for the hypothesis, where the null hypothesis here will be rho S equals 0. Rho S equals 0. What is rho, by the way? What is rho? Rho is this symbol, but what is rho? Erda tried to respond, but you are mute. Unmute first.
Correlation.
Yeah, actually, the rho is parameter for RS. Parameter for RS is a statistic, but rho S is the parameter. I mean, whenever we want to present in our hypothesis, we don't present in the statistic form. We present in the parameter form. Example, when we did our t-test, mu1 equal mu2. We don't write as y bar 1 equal y bar 2. We write as mu1 equal mu2. And then when we go for here, we don't write as RS equals 0, but we write as rho S equals 0. That means rho here refer to the parameter for R, where rho and R are correlation coefficient. When we have the subscript S, that means this is confined to Spearman Rho correlation coefficient. If it is just R, that will be the next topic, which is Pearson product moment correlation coefficient. I mean, with the subscript, this Spearman, without subscript, that will be Pearson correlation. Okay, so that will be our HO, rho S equals 0. That means there is no relationship between X and Y. But our alternative hypothesis can be rho S not equal to 0. If it is not equal to 0, one tail or two tail?
Two
It is not
tail.
equal to 0, one tail or two tail. Anybody?
Two tails.
Two tail.
Two tail. That means when it is not equal to 0, that means it can be positive. It can also be negative. That means we are testing for both. We are testing for whether it be negative or positive relationship. So that will be, if you are testing for both, then we write as rho S equals 0, which is a two-tail hypothesis test. But if you are testing only one tail, it can be rho S more than 0. When we test for rho S more than 0, we are testing for positive or negative relationship.
Positive.
That's right. I mean, if we test for rho S equals 0, I mean, when it is more than 0, I mean, it's a positive value, right? I mean, if we are testing for a negative, for a positive relationship, then our alternative hypothesis should be rho S more than 0. If we are testing on negative relationship on the left side, I mean, our hypothesis, the alternative hypothesis should be rho S less than 0. That means when you are testing for your hypothesis, you need to select which of these alternative hypotheses that you are testing. Either you are testing for two tail, one tail positive, or one tail negative. All right? That means we need to decide. Because why? Because when you go for your RS, the value for your RS ranges between -1 to +1. That will be the range of your RS. So when it can be positive and negative, therefore, it is relevant for you to test for two tail, or you can also test for one tail. But in our earlier discussion for ANOVA and chi-square, we don't have to worry about one tail or two tail, is it right? Why? Because our chi-square and our F ratio ranges between 0 to infinity. That means it will never be negative. Therefore, we don't have to worry about the left side. We are just interested on the right side. Therefore, we don't have to worry about one tail or two tail. We just test for the hypothesis as such. But if the value for the statistic can be positive and negative, then we can test for both a two tail or one tail. If it is one tail, whether in this case positive or negative relationship. That will be the two dimension for your Spearman Rho, descriptive dimension and inferential dimension for Spearman Rho. Okay. Descriptive component. Okay, first of all, what we need to do will be, we need to calculate or we need to derive your RS from, derive if it is from SPSS, calculate if it is done manually. All right. And then in order to calculate for your RS, the formula as we did shared earlier, RS equal 1 minus 6 summation D square divided by N within bracket N square minus 1. Okay, that will be how we calculate for the RS. I mean, when you use this formula, your RS ranges between -1 to +1. That cannot be more than 1, cannot be less than -1. That will be the possible range for your RS. If you happen to get more than 1 or less than -1, then you can, if it is a face-to-face exam, then you can take your red pen, you can mark, and then you just cross, saying that, yes, I know that my calculation is wrong, so you cross your answer yourself. But here you cannot do that because it is done by in our Google Forms, yeah, right? That means you cannot use your red pen to mark that for the wrong answer. So you just let the Google form to do the marking, and then we just receive the result immediately after you submit your form. So that is the beauty about exam using Google Form. Once you submit, automatically your result is there. That means once you submit, I should be able to look at the Google Form, and I should be able to know what is your score, right? And I can see the sequence of who submit the first, who submit the second, and who submit the last for the exam, because Google register the time of your submission. So as compared to face-to-face exam, I don't know. I mean, who is the first, who is the last? But in Google form, it is recorded who is the first person who submit the form and who is the last who submit the form. But based on experience, not necessarily those who submit early scored highest, score high, and not necessarily those who submit later to perform less or doesn't perform in the exam. So it is just random, at random. So you don't have to rush. After all, everyone are given 3 hours for your exam. You are given 3 hours for the exam. So you can utilize all the 3 hours. After all, you are taking your exam at home. You are very lucky, right? Never in history whereby we take our exam at home, unless it is take-home exam. But the normal exam normally will be in exam hall, is that right? So this time, you are taking your exam in your own personal home, your home sweet home. So there will be personal, is that right? So that means with that, you should be able to perform because your spouse will be there, your parent, if you're staying with your parent also there, and if you need assistance, they should be able to prepare for your drink, they should be able to prepare for whatever that you want in order to get a more comfortable environment for your exam, right? You just alert them, okay, additional drink, I want additional drink, and then they will send you the drink, inshallah. So we hope that with the environment, then you should be able to perform, inshallah. Okay, we need to calculate RS or derive RS. Okay, when we derive, or not derive, when we calculate for the RS, the first thing that we need to do will be, we need to calculate D. We need to calculate D. What is D? D is rank for X minus rank for Y. D equal Rx minus Ry. I mean, when we do our example afterward, we should be able to go through how to calculate D for each of the cases. Well, for case number 1, we rank X, we rank Y, and then based on Rx, Ry, we just get the Rx minus Ry, that will give you D. And then we create under the column for D square, and then that D square will be the one that we are going to apply in our formula, where we calculate the total for the D square, that will be entered into this equation, and that will be able, then you should be able to calculate for your RS, right? That will be the basis. And then once you get your RS, then as usual, as I did mention, we can explain the direction of relationship, whether positive, negative, and also we can also explain the strength or magnitude of relationship using Guilford rule of thumb. Right? I mean, if you look through the way that I handle my classes, I will always repeat and repeat and repeat until it is bombarded into your memory, right? Because when we learn something new, it cannot just be once. I share you once, I have mentioned to you, how come you cannot remember? In reality, when we learn something new, we need to be bombarded by the information over and over and over again until it is embedded into your memory. So now I'm bombarded to you with the C4. Okay, the first C4, the second C4, the third C4. Hopefully that will be engraved into your memory. So inshallah, so that will be the descriptive component. Okay, now please fasten your seatbelt. I want to share how to do ranking, how to rank for X and how to rank for Y. The basic concept is we want to rank X, we want to rank Y. Okay, now what we need to do will be, this is our score for X, this is our score for Y. How many cases that we have in this data set? N equal?
9.
N equal?
9.
9.
9.
Equal 9. I mean, we need to rank from first to the last 9, right? First to 9. But we need to decide, if we were to assign 1 to the highest value for X, we must be consistent. We need also to assign 1 to the highest value for Y. That means when we do the ranking, it must be consistent. If we assign 1 to the highest value for X, we also assign 1 to the highest value for Y. If we assign, on the other hand, we assign 1 to the lowest value for X, we also assign 1 to the lowest value for X. Otherwise, the value for your RS will be the same, and the absolute value will be the same, but the sign will differ. Right? The sign, let's say, if you were to do correctly, you will get a positive RS. But if you were to do it wrongly, that means you assign 1 to the highest value for X, but you assign 1 to the lowest value for Y. That means the RS is still the same, but the sign will be different. The sign will be the opposite. If let's say now, by right, you should get plus 0.575. When you do it wrongly, the RS will be minus 0.575. That is if you were to do the wrong way for your ranking. But we must be consistent. Consistent for X, consistent for Y. So in our example, I want to assign 1 to the highest value for X, and I also want to assign 1 to the highest value for Y. Oh, somebody waiting at the waiting room. Okay. All right. Now, how to assign the rank? So we assign 1 column for RX. I mean, RX here refer to ranking for X scores. Okay, so now we want to assign 1 to the highest value for X. What is the highest value for X?
24.
24, that's right. Okay, how many 24? 1 or more than 1?
Just one.
Okay, 1. I mean, only one case, therefore, we assign that rank number 1. Okay, and then for RX, we assign 1. Because that's the highest value and only one case. Okay, the next highest is 20.
1.
21. But now we have how many 21? We have two 21s, right? By right, it should be rank number 2 and rank number 3, is that right? But we don't assign here 2 and 3. But if the score is the same, we need to give average of the ranking. We need to assign average of the ranking to, in this case, to the 2 cases. I mean, in this case, 2 plus 3 is 5. Divided by 2 will be 2.5. Therefore, we assign here 2.5, 2.5. We don't assign 2 and 3, but we assign 2.5, 2.5 because we have duplicate value. We have 2 value for 21. By right, it should be rank number 2 and rank number 3. But in order to rank the 2 cases, we get the total for the ranking and get the average. The average happened to be 2.5. So we assign 2.5, 2.5. Okay, that will be the second highest, 24. The second highest, 21. What is the next highest?
20.
20. Therefore, 20 should be rank number
4.
4. Since we have only one case for 20, therefore, the RX will be 4.
4.
But it should be the next highest value?
18.
18, that's right. How many 18s?
3.
3. Therefore, we cannot simply assign the ranking immediately, but we need to assign the rank in this place will be rank number 5, 6, and 7, right? Okay, what do we need to assign 5, 6, and 7 for the RX? The answer is no, but we assign average of the rank. So in this case, we just need to add the total rank. So 5 plus 6 is 11. 11 plus 7 will be 18. 18 divided by 3 will be 6, 6, and 6. Is right? Okay, the next highest, 16, right? So 16 will be the previous highest was rank number 7. Therefore, this will be rank number 8. So we assign RX equal 8. And finally, 14 will be rank number 9. There's also RX equal 9. And that means now we have done ranking for X, where we assign the variable as RX. So the values are 8, 6, 5, 6, 2.5, 4, 1, 2.5, and 6. That is how we rank for X. So now, if we have done for X, now we want to proceed for Y. Okay, earlier we assigned 1 to the highest value for X, right? So for Y, we assign the RX here, RY. The highest value is 9, right?
9.
I mean, we also assign the 1 to the highest value for Y. Therefore, 9 will be ranked as number 1. The next highest is 8, right? So we have how many 8? 1 and 2. So we assign as rank number 2, rank number 3, and then we get the average to which will be 2.5 and 2.5. Then the next ranking will be rank number 4 will be 7, right? So how many 1? So rank number 4. And then next will be 6. How many 6? 1, 2, 3. Therefore, rank number 5, rank number 6, and rank number 7. So 5 plus 6 plus 7 is 18. 18 divided by 3 will be 6, 6, and 6. Okay, the next rank will be rank number 8. So will be 5. So we have rank number 8 and rank number 9. So 8 plus 9 will be 17. 17 divided by 2 will be 8.5, 8.5. So for the RY, the rank are 6, 2.5, 4, 8.5, 6, 1, 2.5, 6, and 8.5. Okay, once we have rank for X and rank for Y, the next step will be, if we were to do manual calculation, we want to calculate for D.
D.
What is the formula to calculate D that we mentioned earlier?
Rx minus
Rx minus
Minus
RY.
RY. So the first case, 8 minus 6, which is equivalent to 2. The second case, 6 minus 2.5 will be 3.5. 9 minus 4 will be 5. 6 minus 8.5 will be minus 2.5. 2.5 minus 6 will be minus 3.5. 4 minus 1 will be 3. 1 minus 2.5 will be minus 1.5. 2.5 minus 6 will be minus 3.5. And finally, 2 minus 8.5 will be minus 2.5. That will be our D. We don't have to calculate summation D because in our formula, it's not summation D, but summation D squared, is that right? So we just calculate the D for each of the cases. The next step will be, we create another column for D squared. We create another column for D squared, where we need to square each value for your D. So 2 squared will be 4, 3.5 squared will be 12.25, and then 5 squared will be 25, 2.5 squared will be 6.25, and then 3.5 squared will be 12.25, and then 3 squared will be 9, 1.5 squared will be 2.25, and 3.5 squared will be 12.25, and 2.5 squared will be 6.25. Now here, we want to calculate the total. Why we need to calculate the total? Because the formula to calculate for your RS is 1 minus 6 summation D squared divided by N within bracket N square minus 1. So the value that we want is the total of your last column, which happened to be 89.5. That means if you were to use our calculator, the total for the D square is 89.5. That will be what we need to use in our, that we need to enter into our formula. Okay, if you were to enter into the formula, RS equal 1 minus 6 summation D squared divided by N square minus 1. So what is 1? So 1 is a constant. What is 6? Another constant. What is summation D squared? Summation D squared based on our calculation is 89.5, right? So 89.5. Don't square that value because that is already summation D squared. Otherwise, if you were to get 89.5 square, that is not up in the summation D squared. That will be summation D square squared. That is what we want, 89.5. And then divide by N. What is N in our case? 9, is that right? And then 9 squared will be 81 minus 1. And then if you were to solve for this, you will be getting 1 minus 537 divided by 720, which is equivalent to 1 minus 0.7458. That means in your calculation, you need to go to at least 5. Here, I go to only 4 decimal places. Okay, but in your calculation, to get a more accurate and more precise answer for the calculation, try to go, not try, you must go for at least 5 decimal places, right? And then 1 minus 0.7458, the value that you get here will be 0.2542. If the answer that is required is at 3 decimal places, then you can round up to 0.254 if it is 3 decimal places. So here we have to be very precise because when we do our final exam, most probably still online. Therefore, we need to be precise because it's not me who will be doing the marking, but Google Form will be helping me to mark your paper. And the marking is very, very fast. Click submit, done. Click submit, done. Click submit, done. So maybe when everyone have submitted your answers, then I will be getting the mark for each and every one of you. But I need to to follow through, and then I need to enter that into your database. Then only I will release your result after Isha, inshallah. So that means as what we did for our midterm exam, after Isha, then you can request, and then I will be able to share your score. This time, instead of 60, we just change to 90. Instead of 90, will be 95. Instead of 80, we go for 98, inshallah. Okay, for the final exam, right? For the final exam. Okay, so that is how we solve for RS. So the first step, you are given X, given X and Y, and then we need to rank X, rank Y, and then we proceed to calculate for the D, but we don't have to get the total, and then we proceed to calculate D square, and here we calculate the total because that will be the value to be entered into your equation to calculate for your RS, and then once you enter the equation into the equation the corresponding values, then you should be able to proceed with your calculation, and you should be able to get the answer for your RS. Okay, so when you get RS equal 0.2542, what can we say? I mean, we need to describe, is it right? We need to describe the direction, we need to describe the strength. So what can we say about the direction? Is it positive or negative?
Positive.
Positive.
There is a positive. What about the strength? According to
Low.
less than 0.2 negligible, 0.4 low. So somebody have mentioned earlier, what is the strength? According to Guilford rule of thumb?
Low.
Low. That means what we can say is there is a negative, there is a positive and low relationship between X and Y. That is as easy as that to describe on the nature of relationship between X and Y. We look at the sign. If there is no sign, that is understood that is positive. And then based on the absolute value of your RS, then we can refer to the Guilford rule of thumb, and then you should be able to explain the strength of relationship between X and Y. So in this case, 0.254 fall in between 0.2 to 0.4, which is considered to be low according to Guilford. Therefore, we say there is a positive and low relationship between X and Y. That means as easy as that to complete the descriptive dimension or component for Spearman Rho correlation. Okay, any question? Rizwan nampak tengok je tu. Tengah digest ya. Tengah nak klik on save button. Save button. So save. So how to save? Then we need to really focus your attention on the notes, and inshallah you should be able to get it right. Okay, any question? Others? Yeah, Benji, do you want to ask something? But I can't hear you. Maybe you are already unmute, but the sound is too low. Maybe I can hear. You still can.
What about now?
Yes. Okay. Yeah. I can hear now. Okay. Your question?
When we do the ranking, we can also start with the lowest, but both for X and Y use the same method, right?
Yes, you can. And you will be getting the same answer, but it must be consistent. I mean, if you were to assign 1 to the lowest value for X, we also assign 1 to the lowest value for Y. I mean, your answer will be similar to if we were to assign 1 to the highest for X, 1 to the highest for Y. The answer will be the same. But the issue and the keyword here will be consistency. Istiqamah. the Arabic word is istiqamah for consistency. It must be consistent, and the answer will be the same. Okay, others?
Thank you, Prof.
Welcome.
Okay, Prof.
Yeah.
Yeah. In this example, n for X and n for Y are the same. So can it be possible that they have different n's?
Okay. For correlation, the n must be the same. Cannot be different. That means if we have 9 for X, we should also have 9 for Y, because we are getting the score from 9 individual. That means from the first individual, we get his X and Y. For the second individual, we get the X and Y. And therefore, when you go for your correlation, regardless of whether it is a Spearman Rho, Pearson product moment correlation, or simple linear regression, the N must be the same. If let's say we don't have Y for one particular case, the case need to be dropped. Instead of 9 cases, now you have only 8 cases. Does that answer your question?
Yes.
Okay. Earlier, when we go for t-test, ANOVA, the N can be different for each of the group. But here, the N for X, the N for Y must be the same. I mean, if you get the score for X for that individual, you also need to get the score for Y for that individual. Then only we can proceed with the calculation. Otherwise, if we miss certain value or certain score for certain variable, either X or Y, then that case need to be dropped. Need to be dropped. Others, any question? Okay, if no question, then we'll proceed further. Okay, when we want to discuss or we want to explain about the nature of relationship between variable, then we can use our scatter plot or scattergram, right? Scatter plot or scattergram for what purpose? In order to explain the nature of relationship. I mean, this case focus especially on the direction of relationship between X and Y. By looking at the scatter plot, then we should be able to say whether that relationship is positive, negative, or no relationship. So you are maybe given, okay, this is X and Y for the first sublinear distribution, X and Y. This is the first, the second, and the third. Okay, this is A, this is B, and this is C. What can we say when it is A? When we have this pattern of dots in your scatter plot or scattergram? Is it positive? Is it negative? Or is it no relationship?
Positive.
Positive. Why positive? I mean, here currently when we talk about correlation or relationship, we are not we don't really care about the specific line, that represent relationship between the two variables. We just want to see the pattern. So in this case, when you have this dot, the pattern seems to be positive. I mean, if you were to draw a line, that means the line will be something like that, is it right? That means this is a positive relationship. I mean, if X were to be here, Y will be here, is it right? If X were to increase, what happened to your Y? Y will also increases. I mean, increase in X, increase in Y, that is a positive relationship. Or decrease in X, also decrease in Y, that also indicate a positive relationship. On the other hand, if it is B, what about B? Positive, negative, or no relationship?
Negative.
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 What do you mean by negative? That means for negative relationship, if X were to be here, Y will be here, is it right? If X were to increase, what happened to your Y? Your Y will decrease. Right? So increase in X, decrease in Y, that indicate a negative relationship, inverse relationship, right? Negative. What about C? If it is C, is it positive, negative, or no relationship?
No relationship.
I mean, in this case, I mean, it's just random distribution for the dot. That doesn't indicate any direction. Therefore, in this case, we would assume that there will be no relationship between X and Y. If there is any, maybe just negligible relationship between X and Y. Okay, that will be how we want to present the scatter plot or scattergram, which will indicate the direction of the relationship, whether positive, negative, or no relationship. Okay, the Spearman Rho correlation, as we did mention earlier, ranges between -1 to +1. That will be the possible range for your RS, between -1 to +1. Shouldn't be more than 1, shouldn't be less than -1. And that will be the possible range. If you get outside of the range, then for sure the answer will be wrong. Okay. And then in order to explain the strength of relationship, as we mentioned earlier, we will be using Guilford rule of thumb, which says if it is less than 0.2, negligible relationship, 0.2 to 0.4, low relationship, 0.4 to 0.7, moderate relationship, 0.7 to 0.9, high relationship, more than 0.9, very high relationship. Okay, so that will be how we want to describe the strength or magnitude of relationship between X and Y using Guilford rule of thumb. So that means you have, in order to explain the direction, we just need to look at the sign. But in order to explain the strength, we just take the absolute value for the RS, and then based on that absolute value, we refer to Guilford rule of thumb, and then we should be able to explain the strength or magnitude of relationship between the two variables. Okay, that take care for the descriptive component. The inferential component will be the 5-step procedure in order to test for the significance of the relationship. Okay, the first thing I want to share here will be if your n is less than 10. If your n is less than 10, step number 1 will be state HOHA. Step number 2, just report your RS. Step number 3, determine critical RS from table on page 14. And then step number 4, decision. And finally, conclusion. That will be the 5 step. And the 5 step include step number 1. HO will be rho equals 0 against the alternative hypothesis. Rho not equal to 0, 2 tail. Rho more than 0, 1 tail positive. Rho less than 0, 1 tail negative. Where the symbol is, the pronunciation for that symbol is rho, R-H-O, rho. Where rho is parameter for R. Rho is parameter for R, right? Okay, step number 1. Step number 2, no additional calculation. Just report whatever you have calculated earlier for your RS in the descriptive component. Just report that value. And then step number 3, in order to determine the critical value, we refer to this table here. But this table is slightly different from the table that is given on page 14. This table is more detailed table, but we don't have to worry about this table. We just need to refer to the table given on page 14 in order to determine your critical value. I mean, we need to know, are we testing for 2 tail or 1 tail? And we need to know what should be the alpha, and we need to know what is the sample size. Okay, example. Let's see now. We are testing for 1 tail. We are testing for 1 tail, and we are testing at alpha equal 0.05. And our sample size is, let's say, 8. What should be the critical value? 1 tail, alpha 0.05, n equal 8. What should be the critical value? Sorry, ayah ada tak kasi kat situ?
0.789.
Saya ni Sariza. Sariza ada air tak? Kalau tak ada, abang minta pada spouse atau minta pada siapa-siapa yang sekeliling itu. Okay, so if you are testing for 1 tail, that means we refer to the table on the right. And if alpha is 0.05, that means we refer to this column. And n is happen to be 8. Therefore, the critical value is 0.643. If you are referring to this table, is it the same as the table on page 14? Let's see, because sometimes the value, because this is from different source.
Yes, proof.
Same.
Value. Okay, same value. Okay, all right. So that is how we determine. Okay, let's say that is one tail. If we are testing for 2 tail, on the other hand, we are testing for 2 tail, and we are testing at alpha equal 0.01, and our sample size is 7. What should be the critical value?
0.929.
0.929.
That's right. I mean, if you refer to the table on the screen, if it is 2 tail, alpha 0.01, and n equals 7, the critical RS will be 0.929. That is very easy for you to determine your critical value in step number 3. Step number 4, decision. We just need to compare our RS calculated against RS critical. As usual, if it is bigger than or equal to, reject HO. If it is less than, fail to reject HO for manual calculation. If you are using SPSS, we just need to refer to significant RS against alpha. If your significant RS is less than or equal to alpha, reject HO. If it is bigger than alpha, fail to reject HO. Right, so I mean, we need to make sure that we get the right procedure, because I still have an assignment submitted to me where you are supposed to test the hypothesis based on SPSS output. There are still students who still calculate for the test statistic, who still refer to the critical value, and then still compare calculated statistic against critical value to make decision, which is wrong, is it right? If you are given SPSS output, in order to make your decision, we just compare significant value or the P against alpha. Then, if it is less than or equal to, reject. More than, fail to reject. So make sure we use the right procedure in testing for the hypothesis, depending on whether we are using for manual calculation or SPSS. Here in Spearman Rho, not just whether SPSS or manual, for your manual, depend on your sample size. If your sample size is what we have discussed, less than 10, then we will be using this 5-step hypothesis test happening procedure in order to test for the hypothesis. If it is less than 10, right? Okay, that will be in the case where if your n is less than 10, if your n is, or the final step, the conclusion, if you were to reject the null hypothesis, the general conclusion will be there is significant relationship between x and y at whatever your alpha, if you were to reject. If you fail to reject, then we say there is no significant relationship between the two variables, x and y, at whatever your alpha. That will be your conclusion for n less than 10. Okay, now before we go for our break, what is our time now? Our time is 3:22. We proceed to the 5-step procedure. If your n is 10 or more, okay, if your n is 10 or more, we still go through the 5-step procedure. Step number 1, we just need to present our to put forward your HOHA. Step number 2 is not to report your RS, but we need to calculate T statistic. And then step number 3, determine critical T. Step number 4, decision. Step number 5, conclusion. That means the difference between less than 10 and 10 or more. In step number 2, we calculate T, and then step number 3, we determine critical T. Earlier, we just report RS, and then we determine critical RS from table on page 14. But here we will refer to table on page 9 for your T distribution. Okay, the detailed part will be the same thing. I mean, hypothesis will be the same. HO, rho S equals 0 if it is, for your null hypothesis. For the alternative hypothesis, rho S not equal to 0 for 2 tail. Rho S more than 0, it is 1 tail positive. Rho S less than 0 if it is 1 tail negative, step number 1. Step number 2, we want to calculate for our test statistic will be T. When in order to calculate T, the formula is RS minus rho S divided by square root of 1 minus RS square divided by n minus 2. That will be how we calculate for the T. Okay, what is rho S? What is the value for rho S, by the way? Anybody? What should be the value for rho S?
0.
Yeah, according to our null hypothesis earlier, rho S equals 0. That means when we operationalize the calculation for the T, for the calculation, the rho S will always be 0 according to our null hypothesis. And then you just enter your RS, enter the RS square, and then enter n, and then you should be able to calculate for your T. If your RS is positive, your T will also be positive. If your RS is negative, your T will also be negative. That is what to expect for your T value. That means the sign of your T depend on the sign of your RS. Because here the formula is RS minus 0, right? So that means if RS happen to be positive, your T will be positive. If your RS is negative, your T will also be negative. That is step number 2. Step number 3, we refer to the table on page 9 for the T distribution, the T table, and based on your alpha and degree of freedom, and whether you are testing for 1 tail or 2 tail, we should be able to determine the critical value, the critical T. Step number 3. Step number 4, decision. In order to make decision, as usual, we just compare T calculated against T critical. If it is bigger than or equal to, reject HO. If it is less than, fail to reject HO, right? That will be if it is manual calculation. But if it is SPSS, we just compare significant RS against alpha. Significant RS against alpha. If it is less than or equal to, reject HO. If it is bigger than, fail to reject HO. Right? Step number 4. Step number 5, similar to what we did earlier, If we were to reject the null hypothesis, then we're saying that yes, there is significant relationship between X and Y at whatever the alpha. But if you fail to reject the null hypothesis, then the conclusion will be there is no significant relationship between X and Y at whatever your alpha. I mean, regardless of whether whatever your N, we should be able to apply the 5-step procedure in order to test for the hypothesis. But bear in mind when to report RS and when to calculate for T, depending on your sample size. Less than 10, report RS. 10 or more, calculate T in step number 2. Okay, that take care for our this basic initial discussion, so that you should be able to get the overall picture what to expect. After break, then we go for our example. After break, then only we go for example. And we go for example for N less than 10. And then we go another example, N more than 10. And then for the manual calculation. And then we go for SPSS. And then finally, we share how to run the analysis using SLT1. So with that time remaining in our second half, we hope that we should be able to complete our discussion on Spearman Rho correlation. Okay, anything that you want to raise before we go for our break? Our time now is 3:27. 3:27.
Prof.
Yeah.
I have question.
Yeah, so 2 orang bertanya. Okay, Musa and Zaki. Yeah.
Prof, if let's say from the question,
ada berapa orang tu sibling apa ini Musa? Berapa orang anak?
Children 4.
4. Alhamdulillah. How many boys, how many girls? Huh?
1 boy and 3 girls.
Alhamdulillah. Okay. Okay.
Prof, I want to ask from the question how to distinguish or the clue to use either 2 tail or 1 tail.
Okay, as what we did earlier, in order to decide whether should we go for 1 tail or 2 tail, we need to read through the question. We need to read through the question. And then when you read through the question, you ask yourself, is there any indication of direction? The keyword will be, is there any indication of direction? If there is no indication of direction in the question, then that will be 2 tail. I mean, if you are being asked, test the hypothesis on relationship between X and Y. If that is the question, is there any indication of direction, Musa? Test the hypothesis on the relationship, no the indication directions, right? That means if that's the case, that means you will be testing for 2 tail. But on the other hand, if let's say another question says, test that there is a positive relationship between X and Y, then is there any indication of direction there?
Yes.
Yes, therefore, you need to go for 1 tail, is it right? But should you go for rho more than 0 or rho less than 0 when we are testing for a positive relationship?
More than 0.
Yeah, that's it. That is how we decide on whether we are testing for 2 tail or 1 tail. If it is 2 tail, whether it is more than 0 or less than 0. It is based on the question. But if it is based on your research, if your own research for your master's or PhD, then the literature will dictate. Your literature review will dictate whether should you go for 2 tail or should you go for 1 tail. Why do I say that? I mean, if you read through your literature, if it is consistently from the literature that there is a positive relationship between X and Y. Therefore, when you are testing for the hypothesis, you go for 1 tail positive. On the other hand, if there are mixed results, some studies says no relationship, some studies says positive relationship, some studies says negative relationship. That means there is no consistent result based on literature. So in that case, to be safe, you go for 2 tail. That means you are testing for both sides. That means if your own study, the literature will dictate whether you are testing for 1 tail or 2 tail. But for your assignment, for your exam, the question will dictate whether you are testing for 2 tail or 1 tail. What is the key opinion, the keyword, and the key opinion issues that you need to ponder? The question is there any indication of direction? If the answer is no, 2 tail. Yes, 1 tail. But if it is a positive, more than 0, negative, less than 0. Okay, does that answer your question, Musa? Musa dah faham. Zaki? Saya juga faham, alhamdulillah. Musa and Zaki understand now. Okay, since if you have any additional question, we can reserve the question after the break. Our time now is 3:31. Maybe we continue after we start at 3:50. We start our discussion for the second half at 3:50. Is it okay? Any objection? Any objection for the session to start at 3:50?
No objection.
Okay, no objection, alhamdulillah. So again at 3:50. In the meantime, I will pause the recording.
Prof, I have a question.
Ya, teruskan.
According to the question of Cikgu Musazaki just now, okay, so means if the question have a direction, let's say row more than 0, okay, so our conclusion is like this. Is it correct or not, Prof? This is a significant positive relationship.
Okay, you can write that way, or earlier we have already mentioned that there is a positive and let's say a moderate relationship between X and Y. So that means in the conclusion, you can just simply say there is significant relationship between X and Y. But if you want to be more precise, then you can write as there is a significant positive relationship between X and Y. That will be more precise. Right? Or if it is negative, there is significant negative relationship between X and Y. But if you are testing for two-tail, then we cannot highlight on the plus or minus. We can just simply say there is significant relationship between X and Y. If you are testing for two-tail. Yeah. Okay, good. Others, any other question before we start our discussion? What we are going to do here will be we want to share how to do the manual calculation for the first case whereby n less than 10, the second case n more than or equal to 10. Okay, so let's go for the notes. The example. The first example is for n less than 10. N less than 10, I mean up to 9. If it is 10, then it go to the second category, the second procedure. Okay, now the example here will be, okay, example, a study was done to determine a relationship between loyalty and performance. Loyalty and performance. Data were collected from a randomly selected sample as presented in the following table. Okay, that you are given score for X, score for Y, and the number of cases is only 9. I mean, when the number of cases is only 9, that means it falls under the first category, is it right? That means we need to go to the 5-step procedure for the first category, where n less than 10. Okay, now, question. Calculate the appropriate correlation coefficient. Okay, in your final exam, it's just like this. I mean, I will not indicate what should be the statistic to be calculated. I will just say, calculate an appropriate correlation coefficient. I mean, it can be Pearson, it can be Spearman, it can be simple linear regression. I mean, you need to look at the overall question in order to decide on which statistic to be applied. So, but of course, in our example here, our topic is on Spearman Rho. Therefore, this is meant for Spearman Rho correlation. Okay, question number 1: calculate the appropriate correlation coefficient. Second, describe the nature of relationship between the two variables. I mean, when we say the nature of relationship, I mean, we want to know what should be the direction, whether positive, negative, and we also want to know what is the strength of relationship between X and Y. That will be the second question. The third question, test the hypothesis on the relationship at 0.05 level of significance. So, based on the last statement, the last question, is there any indication of direction? Is there any?
No.
Therefore, when we test for the hypothesis, should we go for two-tail or one-tail?
Two-tail.
Yes, we will go for two-tailed. Okay, let's start with the first question. Calculate the appropriate correlation coefficient. In this case, we are calculating RS, Spearman Rho correlation coefficient. Okay, so first of all, what we need to do will be given X and Y, then you just need to rank your X, you need to rank your Y. I mean, the ranking you can do, you can check when you go back, free time, when you have your free time, you can go back and then check how we assign the rank for for X, how we assign rank for Y. So these are the ranking, where in this case, we assign 1 to the highest value for X, we also assign 1 to the highest value for Y, right? So that will be step number 1, rank X, rank Y. The next step, we need to calculate for D. I mean, for each case, we get the Rx minus Ry, and then we get D for each of the cases, the 9 cases. And then we calculate for the D square. That means square each value for the D, we get D square. And when we settle the last column, we just need to total up. And that total up will be your summation D square. And in this case, happen to be 89.5. And that will be your D square, summation D square. Okay, having that, then the next step will be, we just plug in the value. Okay, before I proceed further, I just want to relate to your final exam. In your final exam, you may be given raw data like this, I mean X and Y. Or you may be given the Rx and Ry. That means you are not given the actual score for X, now not given the score for Y. That means the rank has already been done. Can also be given as such. Right? Or you can be given both. That means you are given Rx, you are given X and Y, you are also given Rx and Ry. That means depending on what is given. But if you are given the summary statistic, that means that it will be better, is it right? Maybe you don't have to calculate the rank for X, you don't have to rank for Y. But if you are given X and Y, by now, you shouldn't have any problem how to rank for X, how to rank for Y. I mean, whatever that is given as your data in your exam, for the final exam, you should be able to proceed with your calculation, right? For sure, whatever that is given to you, you should be able to proceed. Don't ask me. I mean, let's say now you are given Rx, Ry. Where is the X and Y? I need to have X and Y. By right, you should say, Alhamdulillah, thank you, God. I have already given the Rx, Ry. Then I just need to calculate the D. I just need to calculate the D square and total up to get the summation D square. And then I can proceed to calculate for my Rs. So in this case, we can calculate Rs. Rs equal 1 minus 6 summation D square divided by n square minus 1, which is equivalent to 1 maintained as 1 minus 6 maintained as 6. And summation D square is 89.5 given based on our calculation earlier. And then divided by n is 9. And then n square is 81 minus 1, which is equivalent to 0.254 at 3 decimal places. If you are asked to present your result at 2 decimal places, then the value will be 0.25, right? Depending on what is the decimal point that is requested in each of the question. Okay, now our calculated Spearman Rho RS is 0.254. That take care for question number 1, is that right? That take care for question number 1, where we have already calculated for the RS. Okay. Now the next step, question number 2, we want to describe the nature of relationship between the two variables. The two variables are loyalty and performance. If you are given loyalty and performance, which one is the IV? Loyalty and performance.
Loyalty.
Yeah,
Loyalty.
The first variable will be the IV. The second variable will be the DV. So that means when we say loyalty and performance, that means the first variable loyalty is the IV. The second variable after the N will be the DV, the dependent variable. So that means in this case, there is, for question number 2, what can we explain about the nature? There is a positive and what can we say about the strength? Low relationship, right? So therefore, we can say there is a positive and low relationship between loyalty and performance. That will be the answer for your question number 2, right? Question number 2, positive and low relationship between loyalty and performance. Okay, question number 3, testing for the hypothesis at two-tailed. Step number 1, state HO, HA. So HO will be rho S equals 0. The alternative hypothesis, since we decided for two-tail because there is no indication of direction, therefore the alternative hypothesis will be rho S not equal to 0. Step number 1. Step number 2. Malay, are you still there? Malay, take your drink, or maybe your sweets or whatever, because you are just listening, or if you were to ask question, then the situation will be different. Okay, step number 2, no need to calculate additional statistic, but we just need to report the RS that we have calculated earlier. So RS is 0.254. Step number 2. Step number 3, we go to the Spearman Rho table on page 14, and then we just need to look at the table. Okay, if you were to look at the table on page 14, we are testing at two-tail. That means we refer to the one on the left, and then alpha 0.05, and then n is 9. Therefore, the critical value is
0.683.
Yeah, 0.683. That will be our critical RS for this example. So now we have the calculated RS 0.254, critical RS 0.683. With that two information, then you can proceed to step number 4, where we can make our decision. So in this case, since our RS calculated 0.254 smaller than RS critical 0.683, therefore fail to reject HO. Is that right? Based on our decision criteria, when your calculated statistic smaller than critical value, fail to reject HO. When we fail to reject HO, what can we conclude? There is no significant relationship between loyalty and performance at 0.05 level of significance. There is no significant relationship between loyalty and performance. That means you indicate the two variables at alpha 0.05 or 0.05 level of significance. And that take care for example number 1. Okay. Any question for example number 1? Musa? Zaki? Musa Zaki? Ada bagus ada dua orang, 2 in 1. Musa, any question, Musa?
No.
Clear? Okay, good. All right, so now we proceed to example number 2, where we have sample size more than 10, equal to or more than 10. So now the example is data solicited from a randomly selected sample were used to measure relationship between working environment and work commitment. Working environment and work commitment. EDA, what is EDA? Exploratory data analysis, the one that we use to check on the assumption of normality. EDA revealed that work commitment data did not meet the assumption of normality. I mean, we from this information, we know that one of the variables, which is in this case our work commitment, does not meet the assumption of normality. Therefore, we need to apply non-parametric statistic, and Spearman Rho correlation fall under non-parametric statistic. That means in your exam, you will be given some hint, like something like that, right? to indicate whether should you apply for Pearson or Spearman Rho or simple linear regression. So you need to really look through the question in order to determine the specific statistic to be applied, and make sure also look for this question in order to decide, especially if you are testing for the hypothesis, whether should you go for two-tail or one-tail. So now the question, the data is as such, X and Y. So in this case, N equal 12. X will be the work commitment, work environment, and Y is work commitment. That means we have two variables. So the IV is work environment and the DV is work commitment. Okay, now question number 1. Calculate the appropriate correlation coefficient. So of course, in this case will be RS. Second, describe the natural relationship between the two variables. The two variables here refer to work environment and work commitment. And finally, test the hypothesis on the relationship at 0.05 level of significance. So similar as what the earlier example, doesn't also indicate any direction. Therefore, this call for two-tail hypothesis test. Is that right? Okay, question number 1. Okay, now for question number 1, first of all, that is the formula, but we need to, from the given x and y, we transform x and y into rank. Rank for x, rank for y, and then we calculate for d for each of the cases, and then we get d squared for each of the cases, and we just need to get the total in order to get the summation d squared. I mean, you can check the calculation, or you can practice your calculation when you have free time at home. Okay, so make sure you get the concept right. We're given x and y, in this case, in our example, and we are supposed to rank for x, rank for y. And then once we have done the 2 column, we calculate d, which is the difference, which is equivalent to rx minus ry. And finally, you create another column, and that column will be d squared. You square each value for your x, and then total up, and that will be summation d squared. Okay, with that summation d squared, you can just plug in into here, which is equivalent to 1 minus 6. Summation d squared is 242.5 divided by 12 multiplied by 12 square minus 1, which is equivalent to 1 minus 1,455 divided by 1,716, which is equivalent to 1 minus 0.1 here. By right should be point here. 1 minus 0.84790. I mean, please place a decimal point here. 0.84790. The point is missing. 1 minus 0.84790, which is equivalent to 0.15210 at 5 decimal places. At 3 decimal places is 0.152. 0.152. That will be our calculated RS in step number, in question number 1, where the RS is equivalent to 0.152. With that information, then we should be able to proceed for question number 2 in order to determine, to describe the nature of relationship. So we can say, since this is positive and it falls less than 0.2, therefore we say there is a positive and negligible relationship between working environment and work commitment. That will be how we interpret the nature of relationship between working environment and work commitment. Positive, negligible. Refer to the Guilford rule of thumb for the absolute value for your RS, especially if it is negative. Then the negative, positive will just indicate the direction, but the absolute value for your RS will indicate the strength. Okay. Question number 3. In number 3, we want to test for the hypothesis. Step number 1 is to state HO/HA. So HO here will be rho S equals 0 against the alternative hypothesis, rho S not equal to 0. Step number 1. Step number 1. Question number, step number 1. Step number 2, we just need to calculate for the test statistic, which is the T value. So T equal RS minus rho S divided by square root of 1 minus RS squared divided by n minus 2, which is equivalent to RS is 0.15210. That means even though we round up to 3 decimal places when we answer the first question, but in our calculation for the T, we go back to the minimum 5 decimal places. 5 decimal places divided by square root of 1 minus 0.15210 squared divided by 12 minus 2, where this 12 minus 2, n minus 2 is the degree of freedom. Is the degree of freedom for your T. Later on, in step number 3, if you want to determine critical value, you need to know degree of freedom. So the degree of freedom is given here, n minus 2. Okay, so if you were to solve for this, what you get is 0.15210 divided by square root of 0.09769, which is equivalent to 0.15210 divided by 0.31255, which is equivalent to 0.48664. And if we were to round up at 3 decimal places, since the fourth value is 6, which is more than 5, therefore you need to increase the third figure by 1, so it will become 0.487. That will be our T. So with this T, do you consider the T to be big or small? The T that we get, 0.487, is big or small? Anybody? Is it big or is it small? This one, big ke small, that value? Because your t ranges between minus infinity to plus infinity. That means infinity is whatever the largest number is, right? So that means if it is 0.487 less than 1, it's considered to be very, very small. Therefore, when we calculate the t, if it is very, very small, what happens if you were to test for the hypothesis? Is there any high tendency for you to reject the null hypothesis? If the t is too small, is there any tendency for you to reject your null hypothesis when you test for the hypothesis? The answer is
yes, sir.
The answer is no. Because in order to reject the null hypothesis, your t must be big, right? But in this case, the t is too small, less than 1. Therefore, naturally, when you test for the hypothesis, the tendency will be you fail to reject the null hypothesis. Why? Because the calculated statistic is very small and most probably will be smaller than your critical value. But if the t is big, let's say like the t is 7, the t is 4, or the t is 10, or whatever the value, then we may, when you are testing for hypothesis, then there is a tendency for you to reject the null hypothesis. But if the t is small, the tendency will be you will fail to reject the null hypothesis. When your t is small, when we run for SPSS, what should be the p value? Should the p be big or small?
Big, large.
Very big.
Yeah, the p value will be big. When we say big, is it possible to be more than 1? Will the p value be more than 1 if it is big?
No.
Because your p ranges between 0 to 1, is that right? That means impossible to be more than 1. That means when we say big, that means it will be 0.8 or 0.9 something, right? The p value. That means when the p value is very big, then the tendency is when you test for the hypothesis, you fail to reject the null hypothesis. Because why? In order to reject the null hypothesis, the p must be small. Must be small towards your 0. Yeah, if it is towards 0, then there is a tendency for you to reject the null hypothesis. Because why? In order to reject the null hypothesis, the p value must be smaller than alpha. It must be smaller than 0.05, or if you are testing at 0.01, must be smaller than 0.01. That will be the general observation that we can observe, even though we just calculate the t value, but we should be able to foresee, should we reject or fail to reject the null hypothesis? The answer is, with this small value for the t, the tendency is you will fail to reject the null hypothesis. Why? Because the t that we calculate most probably will be smaller than the critical value. When it is smaller than the critical value, fail to reject HO. When the t is small, what should be the expected p? When you run for the SPSS analysis, the p should be big. What do you mean by big? It shouldn't be more than 1. It should be, let's say, 0.7, 0.8, or 0.9, something like that. I mean, we would expect the value for the p to be big. When the p is big, then it will be bigger than your alpha. When it is bigger than your alpha, then fail to reject the null hypothesis. I mean, it is consistent. See? If you were to compare t calculated against t critical, fail to reject. If you were to compare significant t against alpha, also fail to reject. I mean, it is consistent. Okay, so that will be step number 2. Step number 3, we want to determine critical value. So in this case, our n is 12. What should be the degree of freedom? Our degree of freedom is
10.
10. Yes. How to calculate degree of freedom? N minus 2. So 12 minus 2 will be 10. And if you were to refer to page 9, if you go to page 9, we are testing at 0.05 for 2 till. That means 0.05 divided by 2 will be 0.025. And you move down until degree of freedom equal 10. So the critical value is 2.228. Is that right? The critical value for the t is 2.228 at 0.05 divided by 2, which is 0.025, and degree of freedom is 10. The t critical is 2.228. So with that 2 information, with the t calculated and t critical, then we should be able to proceed to step number 4. So in this case, since our t calculated, as we mentioned earlier, 0.487, which is smaller than t critical, 2.228. Therefore, fail to reject HO. When we fail to reject HO, what can we conclude? There is no significant relationship between working environment and work commitment at 0.05 level of significance. That will be our conclusion. After all, it's positive, negligible, is it right? It is negligible, but when we proceed with the conclusion, therefore we are saying that there is no significant relationship between working environment and work commitment. Dah, ada apa-apa lagi dah? Ada apa-apa? Okay, sorry, ada somebody coming. All right, so that will be our conclusion as expected, because our T is too small, the tendency will be fail to reject. When we fail to reject the null hypothesis, the conclusion is there is no significant relationship between working environment and work commitment at alpha equal 0.05. I mean, when you state your conclusion, make sure highlight on whether the relationship is significant or non-significant. Also highlight what are the two variables. In this case, the two variables are working environment and work commitment. Also, the keyword is relationship. I mean, significant relationship or no significant relationship between what? Between working environment and work commitment. And what should be the alpha? So in this case, 0.05 level of significance. Or you can just simply say at alpha equal 0.05. That will be the elements in your conclusion. You need to highlight whether it is significant or non-significant. What is the keyword here? The keyword is not comparison, but the keyword is relationship. And you need to indicate what are the variables, the two variables, and you also need to indicate what should be the alpha. Okay, that are the four elements that I'm looking for your answer in your assignment as well as in your exam. Okay, a complete conclusion will indicate that four elements, whether it's significant or non-significant. The first one, where what is the keyword? The keyword is a relationship. Number three will be what are the two variables? In this case, will be working environment and work commitment, and what should be the alpha. Okay, that take care for the conclusion. Okay, so and then if you want to present, you can present the result as such. I mean, we may run a correlation between several factors on work commitment. Therefore, work commitment will not be listed here. We just list the factors. That means what we are saying are working environment and work commitment. Maybe the second variable and work commitment, the third variable and work commitment. I mean, we don't indicate the dependent variable in the table, but the title of the table will indicate what are the factors, and then the dependent variable. So dependent variable in this case will be work commitment. So okay, somebody who is doing the conversation, could you switch off your microphone or mute the microphone? Otherwise, I thought this is question to be answered, but I can't understand the conversation. Okay, so now we present the table, and if you want to write in the APA format, we can say result for Spearman Rho correlation indicated that there was no association between working environment and work commitment, and then we indicate within bracket RS within bracket is the degree of freedom equal 134, and then P equal 1.
卡卡，chờ一会儿，你弄了个啥？咋不在这？你不在这啊？啊。
Let me check who is the one who is.
我暖气停了。你假期不在这？
Dia je. Dia ke lagi singgit kat adik? Okay. Okay, now what we need to do will be, we want to share, if there is no question, I want to share how to run this in SPSS. Ya. Ada orang sampai. Dia nak RM1 ke dia bagi adik RM1? Dia bagi adik ni. Dia bagi adik ni ke?
Upah tadi Kak Adik.
Ya.
Suruh ambil RM1.
Suruh ambil RM1? Betul ke?
Dah sampai.
Mak ni. Dia nak berapa ni tak? Just a moment, sorry for the interruption. Okay, let's go for SPSS. Please, everyone, please open your SPSS. But before we open the SPSS, maybe good idea for you to copy the data set. Okay. Oh no, in this case you cannot copy because the one that you have is currently PDF, is it right? Okay, let me just go to SPSS. Okay, everyone, have you opened your SPSS? Okay, once you open SPSS, click on variable view, and we define the two variables as X and Y. The first variable is X, the second variable is Y. What is X? X is working environment. And Y is work commitment. Okay, the two variables are X, working environment, Y, work commitment. Yuan Roy Chin, what are the scale of measurement for the two variables, Yuan? What should be the scale of measurement?
Scale of
nominal, ordinal, interval, or ratio?
Ordinal.
If you look at the score just now, you have series of score for X, series of score for Y. Should it be nominal, ordinal, interval, or ratio?
Interval.
The answer is interval. Right? The answer is interval, because if it is ordinal, you may have, let's say, 1, 2, 3, 4, 5, something like that. But now you have the actual score. The actual score will be interval scale. So X is interval, Y is also interval. Okay, now once we have defined the two variables X and Y, the next step will be we just need to enter the data set. Right? Okay, in order to enter the data set, just follow me, or you can look at the notes. You can refer to the notes. So the score are 6584, 6584, and then 9675, 9675, and then 4767, 4767. And that will be the 12 cases for the 12 score for X. And then we proceed for the Y. For Y, 15, 34, 11, 15, 34, 11, 9, 17, 12, 9, 17, and 12, and then 13, 23, 11, 13, 23, and 11, and then 13, 23, 11, and then 12, 14, 16, 12, 14, and 16. These are the score for Y. So these score are interval scale. That means we have interval scale for working environment, and we have interval scale for work commitment. Okay, now have we entered have we defined and entered the two variables, the score for the two variables? Are we done?
Wait.
Okay, I will wait. I will wait. If we enter it correctly, our answer will be the same. But if any one of us enter it wrongly, then the result will be different. Okay. If you were to recall, when we did our calculation, Erda, when we did our calculation just now for RS, what was the value for the second example? For this example that we enter into SPSS, what was the value for the RS? 0.152.
152.
That's right. But when I report in the table, I report as 0.134. Could you recall in the opinion notes? When I report in the table is 0.134, and then when I write in the opinion APA style, I also indicate RS equal 0.134. Is it right?
Yes, Prof.
Yes.
0.152. Why the difference? As Warren, why the difference? In our calculation was 0.152. When I report in the table 0.134, when I write in the APA style 0.134, why the difference? Anybody?
No, Prof. That's what I want to ask for.
What is it, opinion, Eswaran?
Actually, I want to ask for.
Oh, you want to ask why the different? Why the different? Okay.
Yes.
Anybody can answer why the different? By right, I should, when we calculate for the RS 0.152, when I report in the table should be 0.152, right? And when I write in the APA style, must also be 0.152. But why I write in the table and in the report as 0.134? Anybody would like to respond for that? Anybody?
Maybe the answer is about RS value, not the P value.
Yeah, the P value was the one that I report 0.678, but we report the RS. But in our calculation, it was 0.152. By right, when we report in the table, under RS should be 0.152, is it right? But why 0.134? Is it an error, a mistake, or is it because of, is it by design?
Because 1.52 is a T value.
No, bukan T. T was apa ni? T value that we calculate was?
Because we use SPSS output.
T value is not 0.134. P value was 0.4 something just now kan? 0.487 kan?
Yes.
Okay. Somebody mentioned just now, the reason is when we go for manual calculation, the formula that we use is 1 minus 6 summation d squared divided by n within bracket n square minus 1. But when SPSS compute for the RS, they use maybe slightly different formula, or maybe the way that they rank is slightly different. Right? That's why the answer is also slightly different. Instead of 0.152, the answer the result given in SPSS output, when we were to run after this, it would be 0.134. And it is by design. That means whenever you calculate for your RS and you compare against your SPSS, the answer will be slightly different. That is opinion memang begitu. This is the only statistic where your manual calculation differ from your SPSS. By right, our manual calculation and SPSS result for SPSS should be congruent. It should be similar. But only for Spearman Rho correlation, the result will be slightly different. Right? So why 0.134? Because when we run for SPSS, then we get the value to be 0.134. That means I choose the value from SPSS output to be presented in our table and to be used in our writing. Okay, let's run this. Once you have already defined the two variables x and y, and then enter data for x, enter data for y. In order to run for this Spearman Rho correlation, we just simply click on Analyze. Click on Analyze. Click on Correlate. Click on Correlate. And then on the right, click on bivariate. Bi mean two variable, correlation between two variable. So analyze, correlate, and bivariate. Once we click on bivariate, simply enter the two variable, X and Y, into the right variable box. Enter the two variable into the right variable box. And then if you want to observe on the left bottom, you have the option correlation coefficient, Pearson, Kendall tau, and Spearman. Right? By default, you are given Pearson, right? So we just untick for Pearson, tick option for Spearman. I mean, we can tick whichever that we want, or we can tick all the three. But in this case, we just want for Spearman, so just tick on Spearman. And then you see here, test of significance. You are given the option, two-tail or one-tail. Remember last time when we discussed on t-test, in t-test, when you run for SPSS or even for other statistical program, you are not given the option for one-tail. But here, you are easily, they can prepare the option for two-tail, one-tail, right? But why they don't provide the option for t-test? Because when you run for t-test, they want to present the CI, confidence interval. In order to present the CI, I mean, it must be two-tail. That's why they don't provide you the option for one-tail. But here, since we can go for, because the output will not present the CI, therefore, they provide you the option for both two-tail and one-tail. By default will be two-tail. So since we are testing for two-tail, so we just maintain, and then just simply click on OK. When we click OK, and then open the SPSS viewer,
Prof.
Yeah.
My SPSS got option for confidence interval.
Confidence interval. You are
Under
using
Bootstrap.
version? You are using version?
27.
27. Oh, this group is very special. Why? Why very special? Because we have 1 to 1, 1 to 2, 1 to 3. Okay. Musa Zaki, in one person ada 2 kan. Tapi for Ainur ada 3 pula tu. Ainur, Yusra, Nabila. Okay, you are using version 28, is it right?
27, I think, because the last I upgrade 27.
Yeah, because if I were to look, okay, let me check my.
Maybe upgrade. Prof.
Mine is also 27. Okay, let me look at my 27. Okay. Okay. You are given here. Okay, let me show you my screen. Let me show you my screen. For that. Okay, this is my screen. So I click on dialog recall, bivariate correlation, and then we already entered the data, right? So the option here will be the correlation coefficient, and then test of significance with the one-tail, two-tail, and then flag significant correlation. I mean, if you want to get the indication, then you can just click on this and show only lower triangle on it. And then what else? That is not I know. Yours kat mana dia bagi option tu?
Under Bootstrap.
And
one more box under Bootstrap.
Before below Bootstrap. Are you sure? How can you check whether you are using version 27? You can just click on help and then click on about, and then it will indicate to you. In this case, mine will be IBM SPSS statistic version 27. Okay, just click on
27.
It's 27.
Yes.
But you have that addition of that. But don't worry about that option because we are not going to use that option. So I thought you are using 28 because mine is also 27. Okay, so just close this one. Okay, now that will be our result. So let me go back to the result page, the SPSS viewer. Okay, so you get this output here. Okay, you get this output here as your result from SPSS. So now you are given this table. If you recall, when we did our ANOVA we are working on summary ANOVA tables. You still recall? Where summary ANOVA table, you have source, sum square, degree of freedom, mean square, F, and significant F. And then when we work on chi-square, we are working on another table. What do you call that table? I know ngangguk je, but what do you call that table when you run for chi-square?
Contingency table.
Yes, that is called
Contingency
table. You may be given 2 by 2 or 2 by 3 or whatever. That are the dimension. But now, when you run for correlation, you will be getting this table. What do you call this table? Where if you look at this table, the value in the diagonal will always be 1. The value in this diagonal will always be 1. And the value for the top and the bottom will be the same. Mirror image. What do you call this table? Anybody? No, Liza, not sure. What do you call this table? Oh, belakang tu apa ni UPM apa ni hall kan, strong UPM hall. So what do you call this table? ANOVA, you call that as summary ANOVA table. Chi-square contingency table. When you run for your correlation, your Spearman ke, atau when you run for your Pearson ke, you will be given something like this table, this type of table. What do you call this table? Anybody?
Is it matrix, Prof?
Yeah.
It's a test.
Rizwan, nak cuba. What do you call that table, Rizwan?
It's step and homogeneity.
Oh, tak ada kan. Tak ada homogeneity kat sini ya kan. Tak ada. Tak apa. Jawapan apa ni? A good trial. At least you participate. So anybody else want to suggest what do you call this table? Or we reserve this for final exam part 1. Tak nak kan? Okay. So what do you call this table? This table is called, the general answer that normally I will get will be correlation table. Yes, but not that is considered to be incomplete, not just simply correlation table, because these are correlation results, right? I mean, we call that as correlation table, but it is incomplete. What is the complete name of this table?
Correlation coefficient.
Correlation coefficient table. Okay, tak apa. Good trial. Okay. But the keyword here will be, the correlation coefficient will be duplicate. The upper diagonal and the upper quadrant and the lower quadrant. And the one in the middle and in this diagonal here will always be 1. That means the RS for the diagonal will always be 1. And for this particular table, there is special name for that. You call this as correlation something table. Correlation something table. What is that something? Correlation.
Diagonal table.
Good try. Okay, let me share you the name. The name is correlation matrix table. MATRIX, not MATRIC. MATRIX table. That means when you have the correlation matrix table, the one in the diagonal will always be 1, and the rest, the value will be duplicate. So in this case, 0.134, 0.134. For each of the cell, we have 3 rows. The first row will be the RS. The second row will be the P value, significant value for the RS. And the third row will be N. That means you have the RS, the P, and the N. That means this cell will be identical to this cell, and the diagonal is 1. Okay, next question. Why the value in the diagonal RS equal 1? Why the value in the diagonal, the value must always be 1? Why? Ni Sarizah nak jawab ni. Dah siap kan? Ni why the value in the diagonal will always be 1? 1, 1. Why? Senyum tu sedekah. Tapi kalau Pak bagi jawapan, lagi bagus lagi kan. Okay, why? Why the value in the diagonal must be 1? If let's say now, maybe.
What we can see, the left is working environment, and then the up one is working environment. So
that means the answer is
variable.
Yes. Bukan maybe. That is the answer. That means these are correlation between the same variable. Working environment and working environment. Also, of course, it must be perfect relationships, right? And then work commitment and work commitment 1.0. Why 1? Because these are correlation between the same variable. That's why the value in the diagonal will always be 1. Later on, if you have more variable, let's say if you were to run on based on data from our assignment 1, then if you run, let's say 4 variable, I mean you have 4 variable, I mean you have 4 by 4. 4 by 4, I mean if you look at the diagonal, will always be 1. I mean x1 and x1, x2 and x2, x3 and x3, x4 and x5. That's why the value in the diagonal is 1. Okay, that is just for your information. If somebody were to ask you, what happened? The other value are the same, but the value in the diagonal 1. So easily you should be able to answer. So in this case, what we can get from here will be RS equal 0.134 and significant RS is 0.678 and N equal 12. You right? Okay, now, if let's say now you are given this output in your assignment or in your exam. Okay, the possible question that will be asked will be, okay, question number 1. Please state what are the variables in this analysis and their corresponding scale of measurement. Please state the variables in this analysis and their respective scale of measurement for the variable. Okay, what should be the answer? Question number 1.
Work environment and work commitment.
Okay, work environment and work commitment, and then scale of measurement.
Interval scale measurement.
Interval for both. I mean, work environment is interval, work commitment is also interval. Okay, question number 2. What is the specific statistic that you use in this analysis? What is the specific statistic used in this analysis? Spearman Rho correlation. How do you know that this is Spearman? I mean, you look at here. I mean, if it is Pearson, it doesn't indicate Spearman. So Spearman Rho correlation. I mean, this is Spearman Rho correlation analysis. Question number 3. For this analysis, do you need to test on the assumption of normality? For this analysis, do you need to test the assumption of normality for the 2 variables?
No.
The answer is no. Okay, justify. Why?
Because it's non-metric.
It's non-parametric.
Because this Spearman Rho correlation is a non-parametric statistic, which doesn't require for the assumption of normality for the data. Okay, that is question number 3. Question number 4. What would be the value for the correlation coefficient? What would be the value for the correlation coefficient?
0.134.
RS equal 0.134. Okay. Question number 4. Is it question number 4? Question number 4. Now 5. What can you describe on the nature of relationship between the 2 variables?
Positive and negligible.
Positive.
Yeah, that means there is a positive and negligible relationship between work environment and work commitment. Okay. The next question, question number 6. So question number 6, part 1. If you were to test for the hypothesis, what should be the appropriate null and alternative hypothesis? HO will be? HO will be
Rho S equal to 0.
Equal 0 against the alternative hypothesis.
Rho S not equal to 0.
Not equal.
Okay. Why do you say not equal to 0, not more than 0, not less than 0? Why?
Two-tailed.
Because
you are given here, see, 2-tail hypothesis test. Because if it is 1 tail, if I were to run for 1 tail, the result will be like this. If I request for 1 tail, okay, here the significant value is 0.678, right? I mean, if we were to test at 1 tail, what would be the value for the significant RS? Is it double or half of that, or the same value?
Half of the.
Yeah, that means we divide by 2. That means we would expect the value to be 0.389, is that right? 0.389. Because why? Because we mentioned that if you are testing at 40 tests, the value given is at 2 tail. But if you are testing for 1 tail, you just simply need to get the significant value divided by 2. And that will be the significant value for, okay, let's try. Pick for 1 tail and then okay. And then the result that you get as expected, is it? The RS still the same, but the significant value will be, so 0.339, not 0.389, 0.339. Right? Okay, that is the reason why we put the HA to be rho not equal to 0. Okay, now it's azan in Bandar Baru Bangi. We stop for a while to give way for the azan to be called. Okay, let's continue with our discussion. The series of questions. The last question was question number 6.1, part 1. What should be the HOHA? So mention the HO will be rho S equals 0. The alternative hypothesis is rho S not equal to 0. The question earlier was, why not equal to 0? Because in the output, you are given in the bracket, significant bracket 2 tail. But if it is significant 1 tail, and then if it is significant 1 tail, what should be the alternative hypothesis?
Bigger than 0 or smaller.
No, so which one? Which one? If it is 1 tail, then they are given here significant within bracket 1 tail. Should it be rho S more than 0 or rho S less than 0?
More than.
Larger than 0.
More than.
That's right, because what we get is a positive RS. Remember, when we are getting a positive RS, that means, and then the value for that means we are testing for a positive relationship. Therefore, rho S more than 0. But if you happen to get the value for your RS to be negative, then for 1 tail will be rho S less than 0. That will be how we present HOHA for the for part 1. Okay, step 2. What should be step 2 if we are testing for the hypothesis? Step number 2 will be, Eswaran, what should be step number 2, Eswaran? Step 1, we set HOHA. Step 2? Your microphone is still mute. You need to unmute your... Erda dah nunggu lama tu kan. Lambat sangat jawapan dia. Okay, so what should be step number 2?
Alpha.
Okay, we set alpha equal 0.05. That's right. Step number 3. What is step number 3?
We have to report.
We just report RS, which is 0.134, and significant RS is 0.678. Step number 4. What is step number 4?
Decision.
Okay, what would be our decision? Should we reject or fail to reject? And why?
Fail to reject.
Why? Why?
Because P is bigger than
significant RS 0.678 is bigger than alpha 0.05. Therefore, reject HO. When we reject HO, what can we conclude based on the analysis?
There is no
significant relationship between working environment and work commitment at 0.05 level of significance. I mean, similar to the conclusion that we did earlier in our manual calculation. I mean, for regardless of whether it's manual or SPSS, step number 1 will be the same. Step number 5 will also be identical, but step number 2, 3, and 4 will be slightly different. Right? 1 and 5 exactly the same. So that means regardless whether you are testing for manual, using manual calculation, or using SPSS output, the step 1 and step 5 will be identical, will be the same. Okay, that will be how we run the analysis in SPSS, and that will be the possible question to be asked when you are given the SPSS output. Okay, finally, before we stop for today, let's run this on SLT. But before you go to SLT, make sure go to your SPSS data, SPSS view data editor, because we want to copy the data set. That means we don't have to enter the data manually. Copy this data set, the 12 cases, copy, and then go to SLT1. If you have opened your SLT1, open your SLT1, go to Spearman Rho, the second option, I mean the option number 16, Spearman Rho correlation, RS and T. That means in this case is N equivalent to 10 or more than 10. For RS, this is meant for if you are testing for N less than 10. So you choose the second option, and then we just paste the value here, the score for X and Y. Automatically, when you paste X and Y, automatically it calculates for you for the rank for the X, rank for the Y. It calculates for you the D. It calculates you the D square, and it also calculates at the bottom here summation D square. That means if you were to do your manual calculation, yeah.
Tak share lagi.
Oh, I didn't share. Oh, I didn't share.
I didn't share.
Oh, I didn't share. So okay, let me go back. Oh, I didn't share the, okay. Okay, when you go to the SLT1, okay, let me go back to SLT1, choose option number 16, Spearman Rho correlation within bracket RS and T. I mean, here is meant for N more than or equal to 10. But if you choose option number 15, this is for Spearman Rho where N is less than 10. So now we use this option here. And then when you go to this option, you just need to paste the data into here. When you paste data for X and Y, automatically it ranks for you for the X, it ranks for you for the Y, and it calculates for you for the D. It also calculates for the D square, and also calculates for you for the summation D square. I mean, if you were to do your manual calculation, in addition to SPSS, you can also check your ranking. You can check also the calculation for your D. You can also check for this D square as well as summation D square. And then you are given the RS equal 0.152, and then if I mean that answer question number 1. For question number 2, what can you describe? I mean, in this case will be positive and negligible relationship between X and Y. We just substitute what is X, what is Y. So we say there is a positive and negligible relationship between working environment and work commitment. That will be the interpretation for the nature of relationship. And then in testing for the hypothesis, we just need to set alpha here, 0.05. And then we select for two tail. If you are testing for one tail positive, you just click here. If it is one tail negative, you just click here. But since we are testing for two tail, just click this option. Automatically, it calculates for you for the T, where T equal 0.487. Significant T 637, which is slightly different from SPSS output, right? When you run for SPSS output, the significant T was significant RS 0.678, 0.678 from 0.687, 0.6780. Okay, but this one is 0.678. But this one is 0.637 because why? Because here in our calculation, our RS is 0.152. SPSS, the value was 0.134. That's why the value is slightly different also for the significant value, the P. And then for the, if you are doing manual calculation, the critical value at 0.05, two tail, 10 degree of freedom is 2.228. And in your decision, if you go for manual calculation, we compare T calculated against T critical, right? In this case, T calculated is smaller than T critical, therefore, fail to reject HO. If you are using SPSS, we just need to compare significant T, which is this one here, against alpha 0.05, which is given as concept to be bigger, therefore, fail to reject HO. When we fail to reject HO, what can we conclude? There is no significant relationship between working environment and work commitment at 0.05 level of significance. I mean, that will be how we present the, we answer for the question. And then at the bottom here, you can see that the patterns of your table to be presented in your report or in your thesis, where you have the title, and then you have the variable or the factors, the first factor, second factor, and so on and so forth, the RS and the P value. That take care for SLT. I mean, if you really want to check your answer, then you can use your SLT1, especially for your calculation for Spearman Rho correlation. Because why? Because the answer for manual calculation is different from SPSS, but it is identical to SLT1. You can check your answer in SLT1. Okay. That will take care for our discussion for this topic. Unless if you have any other question that you want to clarify. Otherwise, we can call for our day today. This will be the day whereby we can complete our discussion at 5 o'clock. Most of the time we go beyond 5, is it right? Yuslan? Any question, Yuslan? Anybody? Have any question about the topic that we discussed
Prof.
today? Yeah.
Okay, Prof. Just
Yeah.
now we know that in order to run to test the hypothesis,
Yeah.
so the second step is to set the alpha value, right?
Yes. Mhm.
So in SPSS, where actually do we state our alpha value?
No need. The answer is
no need.
No need. I mean, you just take the significant value given from SPSS output, you compare that against your alpha.
Okay, or even with testing at 0.01.
And I mean, whatever the value that you get, let's say in our example just now, the significant value was 0.678 and our alpha is 0.01. Since 0.678 is bigger than 0.01, therefore fail to reject HO. Why? Because in this case, we don't want to calculate for the confidence interval. When we don't need to calculate confidence interval, we don't have to declare. Are we going to go for 95% or 99%? So that means for correlation, we just need to get the significant value from the output and then compare that for step number 4 against your alpha to make your decision. That's it. We don't have to declare. And there is no space for you to declare. Unless, I know.
Yes, I have tried. On 99%. I just try an error. And the answer for significant and also the RS is also same with 95%.
The value will be the same. The value will be the same, but the confidence interval, the range, the lower limit and upper limit, that make the difference. But in this case, since we don't have the option for the CI, except for INOR, INOR special. Anybody using 27 where you have the option below the bootstrap, you have another button for CI? Is it CI?
Yes, Prof.
CI.
Yes.
Or
Me too, Prof.
You also have the same thing?
Yes.
Okay.
I posted in the WhatsApp group. That is how the dialog box looks like. Under the bootstrap, we have the confidence interval.
So you ada. Mungkin agaknya you bayar extra kot. You bayar extra to get that extra. But normally dia tak ada. Tapi tak apa. In most cases, we are not interested in the CI. Right? We just take the significant value, compare that against alpha. But if you want to get the 95% CI or 99% CI, then maybe when you click on that button for CI, you need to declare. Are you testing at 0.05 or I mean you can select either 99 or 95% CI. That is the option given, is it right? Erda and Ainur? They have unique version of question 27. Yeah.
Prof, I have question about assignment 7.
Assignment 7. Ini tak asyik ni, aku jawab. Kalau boleh jawab, saya jawab.
Okay, question number 2 is regarding data from assignment. So, how about the direction, Prof?
Direction. What do you mean by direction?
I mean the HO and HA. Is it we consider no significant or have a direction?
Okay.
And then Prof. Okay. In a Spearman Rho, we decide to use whether our data both ordinal or interval, but one or both variable is not normal distribution. So we consider which one, Prof, to our assignment.
Okay, good observation and good question. Okay, question number 1. Should we go for one tail or two tail? Because it doesn't indicate whether you are testing for there is test for the relationship or test for positive or negative. So that means in order to answer for that, the answer will be test for two tail. Test for two tail. That means regardless of whatever variable that you have selected, you are testing for two tail hypothesis test. Okay, question number 1. Question number 2. Question number 2, should we select the two variable to be ordinal and ordinal or the two variable as interval ratio? My choice will be you need to select the one that is interval or ratio scale. Because why? If you were to select the one that is already been recorded into categories, that means you have only 1, 2, 3. That means if you were to rank, then the ranking will be crowded, is it right? Because duplicate of 1, duplicate of 2, duplicate of 3. But if you are using the actual score for your variable, the actual score based on your computed variable, then you have variation in the score. Because scale 1, I mean, you have, when you group them into 3 level 1, 2, 3, level 1 is in between 1 through 2.33, is that right? That means anything between 1 through 2.33, we assign level 1. If it is 0.234 up to 3.669, and we assign that as level 2, is that right? That means the range of value will be big. Therefore, the better choice will be you need to select the 2 variables which are interval or ratio scale. But make sure, one will be IV, the other one will be DV. Okay. Another question about question 2, part 1, part 2. Question 2, part 2. Question 2, part 2 will be from Noliza just now. Do we need to test for the assumption of normality? Okay, the answer is, in this case, no need. Because remember, what is non-parametric statistic? Non-parametric statistic doesn't require your data to be normal. But if your data is normal, you still can apply for Spearman Rho correlation, right? You can still run for Spearman Rho correlation because if it is normal, but a better choice will be Pearson product moment correlation. But if you were to still, even though it is not normal, both the distribution are normal, the distribution for X is normal, distribution for Y is also normal, and you apply for Spearman. This is considered as not a haram, but sunat, but macro. And I mean, it is not the right choice. The better choice will be if both are normal, then we apply Pearson product moment correlation. But if both are normal, we still want to apply for Spearman Rho, no problem. There is no opinion that it's not considered as prohibited. Yeah, question.
One more question.
Question number 3.
Okay, in case we choose the second one, which is both is a normal, and then we run with a Spearman. Okay, it's better using Pearson, right? Okay, my question is it the value different about Spearman and Pearson?
Yeah, totally different. Because when we calculate for Spearman Rho RS equal 1 minus 6 summation D square divided by N within bracket N square minus 1. Now, that is the formula to calculate for the RS, which is based on ranking for X, ranking for Y, remember? But when we go for Pearson correlation, the R, in order to calculate R, the formula is SXY, which is cross product sum of square, divided by square root of SSX, which is sum square for X, multiplied by sum square for Y. That means that will be the basic formula. Cross product sum of square divided by square root of SSX multiplied by SSY, which is equivalent to what is cross product sum of square? Cross product sum of square is summation xy minus summation x bracket summation x bracket square divided by n, and then divide by square root of sum square for x is summation x square minus summation x bracket square divided by n, multiplied by summation y minus summation y bracket square divided by n. And I mean, that is the formula to calculate for your R, which we will be discussing inshallah next week. So the formula is totally different. One is based on ranking. The other one for Pearson, the calculation is based on the actual score. So when you run, even though you run the same variable, you can see that the result will be different because one is based on ranking, one based on score, and then we have 2 different formula for the calculation for Spearman Rho and Pearson product moment correlation. Okay, that is your question number 3. Does that answer your question, Noliza? Okay, our time now is 5:05. But still, I can entertain for if you have any question. Any other question for Spearman?
I have question, Prof.
Yes. Okay, now it's Yusra. Yusra is asking me his question. Okay, Yusra.
Let's say my RS is negative 0.9. So we can take absolute value. Let's say our interpretation is negative and very strong, very high relationship, or just negligible because it is negative.
Okay, if you recall, as I did mention earlier, the sign will indicate the direction, but the absolute value will indicate the strength. Therefore, if it is minus 0.9, we say there is a negative, and 0.9 fall under very high relationship, right? Therefore, we say there is a negative and very high relationship between X and Y. Not to make mistake, because if you consider the whole thing minus 0.9, of course, as if it is less than 0.2, is that right? But in order to decide the direction, we just refer to the sign. But the strength will be based on the absolute value of your RS. The same will be also true later on next week when we discuss on Pearson correlation. Once we get the R, whether it is positive, negative, whatever the value, the sign will indicate the direction. The absolute value of the R will be the strength of relationship between the two variables. Okay, so good observation and good question, just to make sure that we get the concept right. Are there any other question? None. Alhamdulillah. Yusran, ada soalan tak? Pakai baju Melayu dah cantik dah tu. Okay, tanya soalan satu. One question before we stop.
Sorry, Prof. I have a question.
Oh yeah. Go. Okay.
Yes. There one point I want to clarify that the rank's meaning is what?
What is the meaning of ranking?
Yeah.
Are you asking what is the meaning of ranking? That means we assign a sequence based on the size of the score. We arrange the score in sequence, and we assign the number. I mean, we assign from the highest value to the lowest value, or we assign from the lowest value to highest value, and then we assign number accordingly. That is ranking. Let's say now, based on our midterm exam, if we were to assign one as the one to the highest value for test midterm exam, so that means our friend who get 93 will be ranked number 1. And our friend who get the lowest score will be ranked the last, they will be given the last ranking. I mean, if let's say the total number of students in my class is, let's say, 97, so the last student will be ranked number 97. But if you have duplicate, as what we did earlier in our calculation, if you have duplicate of values, then we don't assign as 6, 7, and 8, but we get the average of the ranking if the values happen to be similar. Is it clear, Gal? Okay, make sure practice your ranking, because if your ranking is done incorrect, then the whole calculation will be wrong. So make sure practice your ranking, rank for X, rank for Y, and you can check your calculation using SLT1. I mean, if let's say now you just give any number, you give number, and then you start to rank, and then you enter that number into your SLT, and you can compare what you have done manually against SLT. Make sure your ranking is correctly done. If it is wrongly done, then the whole calculation will be wrong. Okay, Gal? Okay, now Yuslan, ada soalan tak? Tak ada soalan?
So far, no, Prof.
No question. Okay. So since
thank you, Prof. Thank you.
Okay, welcome. So since there is no question from our friend, so my assumption is most of you have learned to a certain extent on Spearman Rho correlation, where when we did our discussion, we mentioned that when you go for Spearman Rho correlation, it falls under the non-parametric statistic, and the focus is on to determine relationship between two variables. And in order to apply for this Spearman Rho correlation, we must make sure that the two variables are either the basic requirement ordinal. But in most cases, we apply Spearman Rho correlation when both the variables are interval or ratio scale. But at least one of the variable is not normally distributed, or both. But if both are normally distributed, still you can apply, but that is not the right choice. The right choice will be Pearson product moment correlation. And then when we discuss about our Spearman Rho correlation, we mentioned that it comprises 2 dimensions, descriptive and inferential. What is descriptive? We calculate or we derive RS. And then once we have derived RS or calculate RS, and then we should be able to explain. What is it that we can explain? The direction of the relationship as well as the strength of the relationship. That take care for the descriptive dimension for Spearman Rho correlation. The inferential component will be when you are testing for the significance of the relationship using the 5-step procedure in testing for hypothesis. But we need to be aware, we have 2 procedures in testing for the hypothesis depending on your N, the sample size. If N is less than 10, then in step number 2, we don't need to calculate additional statistic, but we just report the RS. And then step number 3, we go to table on page 14, the Spearman Rho table, and we should be able to determine the critical Spearman Rho critical. And then step number 4, we just need to compare calculated RS against critical RS to make our decision. But if your N is 10 or more, then in step number 2, we don't report RS, but we need to calculate another test statistic, and that test statistic will be your T value. How to calculate T? T equal RS minus rho S divided by square root of 1 minus RS square divided by N minus 2. And when we calculate for the T, depending on the sign of your T depends on the sign of your RS. If your RS is positive, your T will also be positive. If your RS is negative, your T will also be negative. And when we calculate earlier for the RS, RS ranges between -1 to +1. Shouldn't be more than 1, shouldn't be less than -1. And then make sure once you have done your assignment, after you have done manually on your own, please check your answer against SLT so that you are not making the unnecessarily mistake. Otherwise, you will not be getting 10 for your assignment 7. So we want to make sure that from assignment 5, 6, 7, 8, and 9, we will be getting 10 out of 10. So that will boost our overall grade for ERS 5950. Okay, so thank you very much, and make sure for this assignment 7, it is not due this Saturday, but will be due on next Saturday as usual. Okay, so thank you, and we meet again inshallah next week for our next topic on Pearson product moment correlation. Okay, until then, Assalamualaikum warahmatullahi wabarakatuh inshallah. Bye bye.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof.
Okay, welcome.
Thank you, Prof.
Okay.